Okay. Good morning. Good morning, DevOps. Hey. So you made it all here on a Monday morning, and quite a lot of you too. I'm a little bit impressed. I thought like these pre-conference sessions are usually a little bit smaller, so I was expecting like maybe 100 people or so. So yeah, there's a lot. And really happy with that, so we can all go in and dive into Java 21. So why am I telling you about this? I'm Nicolai Parlog, Java developer advocate at Oracle. So talking about new Java stuff is kind of what I do. But specifically at this conference, you don't have to listen to just me. Brian Getz is here, for example, Stuart Marks. There are many people who don't just talk about this, but actually work on this who are here as well. And I can only recommend watching their sessions too. But today we're going to look at not just 21, but 18 to 21. I guess many of you are here interested, are probably on 11 or 17. So we're going to summarize everything that happened after 17. And you'd think we'd have enough time, right? Well, we don't. It's like it's too much. It depends on the level of detail you go into. And instead of going into everything at a surface level detail, I want to go into a few important things very deeply and leave a lot of other things on the table. Not a lot, but a few other things on the table. So you can always go to the Java YouTube channel and have more details on much of this. I can also highly recommend to check out the slides. They should already be online, and except for this one, which I just fiddled a little bit with. They should look as you see them here. It says hit question mark for navigation help. And you'd think, I don't need this. I know a slide deck works. Just keep it in mind in case you realize that you don't, because it's two-dimensional and it's very confusing if you look at it for the first time. It looks like this. So just saying, if you want to follow along with the slides, hit the question mark early. And if you have any questions, you can try to raise your hand and then yell it. But understand that that's not everybody's cup of tea. So you can also tweet at me, / you can also blue sky at me, or you can also toot at me. And I'm always NepaFX. You will find me on Mastodon. And I have my phone here, and I'll try to look into it every now and then so that I can see whether there's a question that I can reply to right now. Good. We're going to take a break in the middle, and we have lots to cover, and I'm pretty sure I'll do some prologue and all of pattern matching, and then we're probably going to take a break. Maybe it's a little bit before the halftime, and then after that we're going to go through just as much as we can in the remaining time. Before we get into it, why would you even upgrade? There are two kinds of costs. One of them is the actual cost of running an old version, which means you probably have to start paying somebody soon. Like if you're Java 8 still, for example, you definitely have to start paying soon if you don't already. And support in libraries and frameworks is getting less and less, right? If you're on Java 8, for example, you can already not update to new Spring versions, and that's not the only example at all. So there are many libraries that now require newer versions. Bigger maybe is the opportunity cost of not running on a new version, though. Definitely new versions give you a higher productivity. That's what all the features that I'm going to present to you, or many of them, will be about. You get less observability, less performance. You have probably less access to talent, because imagine telling somebody that they can work on Java 21 versus they have to work on Java 6, and then somewhere in between, it's like there's a curve there. And the upgrade costs are going to become bigger. It's going to be easier now to go from 11 to 17 or to 21 than it's going to be in 5 years. Because in 5 years, you can no longer just update everything and then move with Java, move the Java version. That's what you can do now. If you're now on 8, as I just said, you already cannot do that anymore. Because you cannot just put everything on the newest version, because then Spring is going to tell you, well, for Spring Boot 3, you actually need Java 17, I think. Oh, 21? Well, one of those two. But the most important one maybe is, it doesn't even matter. Why would anybody fight upgrading, right? I know I'm probably preaching to the choir here. Many of you want to upgrade, but just in case you have to talk to your manager about this, one thing you can tell them is, look, do you want our project to die within the next 5 or 10 years? Because if the answer is no, we're going to have to do the update anyway. Why not do it while it gets us some additional bonus instead of always being far behind, but still having to do the work anyway? There's some preparations that you can take to make sure that your recent or future upgrade goes well. And that's not only for Java upgrades, by the way. Much of this also applies to upgrades of big frameworks or libraries. So the important parts are that you have to stick to supported APIs and standardized behavior. Most of the upgrade hurdles don't so much come from backwards incompatible changes, and that's also true in your dependencies, not just in the JDK. Many of these issues just come from you intentionally or accidentally, depending on the behavior that the provider of that dependency considered to be internal, considered to be an implementation detail, but you happen to depend on it. And that happens quickly, I understand, but still try to avoid it if you have the chance. Read close to the documentation and try not to rely on behavior that goes beyond what is promised in documentation, for example. If you have a choice between different libraries or frameworks, consider or give an extra benefit to the one that is well maintained. If there are ever any changes in Java that this dependency needs to upgrade to, if it's well maintained, obviously they're much more likely to do that soon. Try to keep everything up to date. That's good for your Java update. That's also good for a lot of other reasons during development. So, like set time aside in your projects to upgrade dependencies and tools. Again, probably you're already aware of this. Sometimes management has issues with it's working as it is. Why would we need to invest time into updating Log4j? For that one specifically, maybe you can give them a good example. A good way to stay ahead of removals is to use JDepreScan. JDepreScan, you throw some bytecode. It's a command line tool. You throw some bytecode at it, like a jar, like your jars, or all your dependencies jars, and it will tell you which APIs are being used that are deprecated, and that way you can track that and can make sure that those becomes less and less. But maybe the most important, because it's the most practically applicable thing and gives you feedback on almost all of these points, is to build on many JDK versions. If you're having a project that you run in your cloud or on-premise, like you have control over, there is a good chance that you feel like, well, we're running on Java 11, all we need to do is build on Java 11. I'm here to tell you that consider building on more Java versions. In that example, yes, definitely, of course you need to build on 11, right? But also 17 is still supported, so build on that. 21 is the latest version, build on that. Actually, you can already build on 22 early access. Build on all of these versions. Even if you have full control over where the project runs, and none besides 11, as an example, will ever be used in production, do yourself a favor and build on all of these versions. This gives you the most insight into any changes that you're making or any dependencies that you're pulling in that might cause issues down the line. So for example, if there's a deprecated API that was deprecated in 21, even though you're still on 11, maybe you want to stop piling code on top of that deprecation, right? So you want to know that as soon as possible. And if it's not necessary, and it's not necessary to build every commit against all of these Java versions, right? I mean, you can if you have the resources available, but you don't have to. If it's too time intensive or just costs too many resources, just build maybe nightly, right? That would be enough to let you know, oh, something we did yesterday, causes issues on Java 22 early access. That's good to know. And then you can look into it and learn what's the issue and then fix it. One more thing that we have to talk about when we talk about Java 21 is what's long-term support. Isn't Java 21 an LTS version? And I'm here to tell you Java 21 gets a lot of long-term support from lots of companies out there. I'm working for one of them. But that doesn't make Java 21 an LTS version. It feels a little bit like being pedantic, but making that distinction really helps understanding what's going on in the Java ecosystem and the community. Within OpenJDK, which is the body that creates the reference implementation of Java, there is no such concept as LTS. Right? It just doesn't exist. If you go to github.com/openjdk/JDK, you will not find any mention of that concept. Vendors do that. Vendors offer you support or maintenance for paid contracts or for free. Like there's a lot of things going on there. Basically, you're paying not to get new features, is how Ron Presta once put it. That's the very short version. So don't worry. Yes, you will get long-term support for Java 21 from lots of different vendors. But that does not make Java 21 an LTS version. Just like 17 isn't one, 11 wasn't one, and 8 wasn't one. This is not new. This is not unique. It's just something that I feel is important to explain. This was the short version. This is the long version. I'm going to spare you that. But if you want to look into that, I made a video on the Java YouTube channel where I explained to people why Java 21 is no LTS versions. And I got a lot of pushback for that phrasing. It's like, isn't that clickbait? I don't know. It's not wrong. It's actually technically very correct, and that's what I explained the whole video. So I don't know. I don't think it's clickbait. But yeah, it's easy to misunderstand. So do yourself a favor, watch the whole video. Okay. Done with all of that, let's do some new cool stuff. Let's talk about pattern matching. We're going to split that into two things. One is we're going to look at pattern matching as a new approach to dynamic dispatch. And the other one is we're going to talk about data-oriented programming. Let's see whether I get any questions. Doesn't look like it yet. Oh, maybe? No? No, I don't think. Okay, let's talk about pattern matching. I brought a very simple app as an example. The goal here is that it scrapes GitHub projects. You point at a GitHub project and just start scraping all the pages there. And it creates instances of a type, where's my cursor? There it is, of a type called page. And we have different kinds. We have issue pages, pull request pages. We're going to assume GitHub doesn't have any more pages than those two, for simplicity's sake. You know, sometimes a GitHub project links to an external page. We want to grab that too, but we stop exploring there. We just noticed somebody linked to Wikipedia. We're not going to scrape Wikipedia too. And then maybe we get an error somewhere, a link is dead. And so, you know, that's the kind of pages that we create, and then we further process them. The code that does this lives in this method. It says load page tree, and then does a lot of interesting stuff, and eventually returns a page. If you want to look at that code, it's on my GitHub. And the reason why it's called Loom Lab is because this part, the load page tree method, internally uses virtual threads to do its thing, which is kind of interesting. So you can check that out there as well. And then on top of that, it could do all kinds of things. Of course, it does none of that because it's actually complicated, but you know, it's because it's a demo app. But like, it could do things on these pages, like display them as an interactive graph. You could, since it is a graph, compute some graph properties on it. You could try to categorize pages by topics, like what is this project mostly working on? Maybe you want to see how toxic it is or how good the mood is, by do some mood analysis. You know, if you offer this, all these features, maybe you want to charge for them, so you have process payment. You have like a lot of different things that all use the page type. So how do you implement this? Where do you put those features, right? Where do you put the process payment method that uses a page? Or the analyze mood method that uses a page? Or the, you know, something that computes some graph properties? You could just put them all on page. But if you do that, you have one class that has a method like process payment and then knows some payment provider. And then you have it like, I don't know, maybe you want to paint it on a canvas. So it gets like paint, has a paint method that gets a canvas. So suddenly you have a type in your system that knows all the other subsystems, which are super different from one another. And you definitely don't want to have all of them collide in the same place. So you're like, how do I divorce operations from types? Isn't there like a pattern? So yes, you can look it up and it's a visitor pattern. If you've used it in the past, you start crying because you know, like it's the best solution that you have, but it's still not one that you like to use. If you've seen a lot of visitors in a code base, again, I'm not harping on the pattern itself. It's the best solution that we used to have. I'm going to show you a better one in a second. But it's still very indirect, and specifically for beginners, it's hard to wrap the head around and always causes issues. What you can also do, by the way, is type checks, which is super scary. So let's do that. Let's do just type checks. I mean, what's the issue, right? You could just say, look, if page is an instance of GitHub issue page, I'll just cast it, and then I'll categorize the issue page. So the idea here is that I have this categorize method that gets a page, but it needs to distinguish by type. But if you put this on page, page has page.categorize, and then you have a different implementation for each different type. But then you do have it as part of the API, which is what I wanted to avoid. So we do it the other way around. We get a method that accepts a page and just does type checks to figure out which type it is. And let's ignore the reason that half of you now want to get up and leave this talk. And let's work on this. And we'll see that we get somewhere reasonable in the end. First thing we can do, we can apply type patterns, which is a feature that you might already have used if you're on 17. It was finalized in 16. And a type pattern combines three things. It combines a type check, the declaration of a new variable, and the cast of the variable into the new one. And so this kind of common pattern that happens in code bases all over, it shouldn't happen a lot, but you know, it's part of most code bases, is this way standardized and just made more feasible. And all you do is you write if page instance of GitHub issue page, and then you write issue there, which is the name of a new variable. If you just look at the first three words, it looks like an instance object. If you just look at the last two, it looks as just like a regular variable declaration. And so what happens here, if page is indeed an instance of GitHub issue page, a new variable of that type is created, and then issue is of the name issue, and then page is cast into it. You know, we can do else if to all the other ones. Talking about patterns for a second, this what I just described with type patterns, that they do the instance of check and then declare a variable and then cast into that variable. That is easy to generalize to doing a Boolean check, declaring one or more variables, and then somehow extracting some interesting property from the variable that I checked into these new variables. In our case, there was no really an extraction. It was just like an assignment but with a cast in there. And that's what patterns do in general. You do like, if this property is true, then create that new variable and assign a value. And we do that so much. For example, if the list is not empty, create a new variable and give me the first element. If the map contains this key, declare a new variable and assign the key's value. And there's like infinite examples of this. And what patterns do is formalize this and give us a common approach to all of these. And the only pattern we have seen so far is the type pattern in Java. Okay, let's throw something else into the mix. Let's start using records. It's a little bit of a detour. We'll see in a second when that becomes interesting. They're finalized in 16. If you are on 17, I'm sure you've used them a lot already. For those who haven't seen them so much, I want to give like a brief introduction. This is a record. It's like class, but instead of class, you write record. And instead of after the name writing the body of the type, you put something here which is called a component or list of components. This one has two, a URL and content, of these two types. And the interesting part is about a record that the compiler understands the internals. It couples the API to these internals, and that reduces verbosity a lot. So let's look into this. The claim here is they're transparent carriers for mutable data. I get external page, which I showed earlier, which is final. I get private final fields for the URL and the content. I get a constructor that looks exactly like this component list I just wrote, which gets both of these parameters and just assigns them. I get accessors, you could call them getters, which they don't have the get prefix, thankfully. So just go with URL and content and to get URL and the content. You get an equals hashcode toString that uses all the fields. And the reason why you get all this is not because records want to avoid boilerplate. They do that, and that's great, but don't use that as a lens to look at them through. Because if you do, you're going to be disappointed, because sooner or later you want to avoid a lot of boilerplate, but you still want to have this one special thing in there, and records are going to tell you that doesn't work. And you think, well, they're a really bad boilerplate avoider. Which, again, they're not. They're not there to avoid the boilerplate. They're there to be transparent carriers for immutable data. Both of those parts are very important. And we're going to look at the transparent carriers part first, because now we can look at another kind of pattern. Look at record patterns. They were finalized in Java 21. They also check whether variables of a specific type, but what they do then is they declare one variable for each component. And then they assign the components to those values. So if a page is an instance of external page, that part we've seen before, but now we destructure external page into its two components, URL and content. And then if page is indeed an instance of this type, these two variables, URL and content, are in scope in this if branch here, and they have been assigned the URL and the content that the external page instance had. So what you would do without deconstruction, you would write if page instance of external page, and then new line, cast page to external page, create URL and content, and assign external page.url and external page.content. So that's like just a bunch of lines that now just get compressed into this one expression. So again, a common pattern of give me these pieces of data that are in that type, hand that out to me. And that works only because records are transparent, right? Because the compiler knows that there's nothing hiding. They're transparent carriers, meaning every data that they contain, they're exposed through the API, and the compiler understands that well enough to use the accessors here, right? So there's no magic involved. There is no having to use reflection to get at the fields called URL, because there will be an accessor called URL. And that accessor is used. And if you put code in there, it will be executed during the deconstruction. OK, good. So what do we have now? We had the type patterns and now the record patterns. We have seen how to use them with instance of. which is, you know, one way to get there to where I want to go, but it's not the main way you're going to use them. The main way will be in Switch. And that's the important part. That's why I'm talking to you about pattern matching now in Java 21. That was the last piece to the puzzle. Record patterns are nice, but they're not necessary to use pattern matching. This is necessary to use pattern matching. And this has only been finalized in Java 21. So what I do here is I write switch page, and then I write a case label for each type that I have. So let's say I have a page, I said earlier I have GitHub issue pages, I have external pages. Let's just use these two for now. And here I can use any kind of pattern. This is a type pattern in a switch. In case this instance is an instance of this type, declare this variable of this type, then an arrow, you know, and if it wouldn't be on slides, but in an IDE, the arrow would go to the right and it would actually look good. And then we can call this method with this variable. That's the type pattern in a switch. The line below that uses record patterns in a switch. It says, okay, in case it's an external page, take it apart into the URL and the content, because for categorizing external URLs, I don't know, I don't need the URL apparently. So I'm taking this apart with a record pattern. So what I'm doing here is applying patterns in switch. And that's going to be the main way to do that because of the compile error I'm getting. So let's assume page, as I said earlier, has 4 subtypes, right? Let's assume I've listed all 4 subtypes. Then we know, well, I mean, page apparently is an interface. There could be other implementations out there, but if they're not, then we covered all the cases, right? But the compiler is not happy. The compiler tells you the switch expression does not cover all possible input values. Maybe it doesn't say expression here, but statement, but I'm not sure. You will get an error very close to this one. Which possible input value did we miss? Well, all the other possible page implementations, right? As I said earlier, there's like pages and interface, so there can be many more implementations, and all of those would fit into none of these cases, right? All of these cases would leave them out, the new type would fall through, and that's not good. And that is why a switch demands exhaustiveness, to give you this kind of like last line of defense against, but what happens if new types come in? So whereas an if-else-if chain doesn't need to cover all cases, right? You can just give me an object, and if it's a string, do this, if it's an integer, do that, otherwise, I don't know, I don't care. Right? So with a switch, you cannot do this. The switch needs to be exhaustive, is what's that called. It needs to cover all possible input values. And the only way we can do that right now is to say, well, if it's not one of the 4 that I know, then it's a new type that I don't know anything about. Just let's throw a legal argument exception. And if you felt that type checks are icky and they should be avoided, then we're getting very close to why that's the case here. So let's look into that default branch. Let's look into this last line of defense against new types. What else can there be done? And there's one thing that has been finalized in 17 that you could use if you're on 17, but I doubt you did because it didn't get you anything within your coding. It helped communicate to your colleagues, but that's it. So you can have sealed types, and they limit inheritance by only allowing specific subtypes. So if you write, let's talk about interfaces for simplicity's sake. If you write an interface, everybody who can see the interface, meaning within the same class package or within the entire JVM, can create an implementation of that, right? That's just very simple. Everybody can do that. On the class side, you have something similar, although the complexity is added by the constructor has to be reachable. Or you can make a class final, right? So with interfaces, you have no choice. Everybody can implement it, who can see it. And with classes, you can make them final to prevent any extension, or you can play some tricks with the constructor, but pretty much you're always in the case where the number of implementations or the kind of implementations are unknown to you. And sealed types give us another way to do this. You can have sealed classes as well. I'm going to focus on sealed interfaces because then they make things simpler. If you look into this closer, or if you experiment with it, you will eventually figure it out. It's not a big thing, though. So public sealed, I put the word sealed here, interface, page, and then I write permits, and these are the specific types that it allows. So these are the 4 types I mentioned earlier. If I now write a new class and says my page implements page, it doesn't compile. The compiler tells me, no, you told page that there will only be these 4 implementations. This isn't one of them. Bugger off. Like this doesn't work. Get a compiler error. And that is great, because that works perfectly with how switches consider exhaustiveness. Because if all subtypes of a sealed types are covered, then the switch can be exhaustive without a default. So I'm switching over the page here, and if it's case it's an issue page, I do something, pull request external error. Like in all these 4 cases, I do something. And now I'm exhaustive. I've covered all possible extensions of page because page is sealed, and the compiler is happy. I don't get a compile error. This compiles just fine, but it's still watching and will still help us. Now let's face the fear of type checks. What's the reason why we don't want to type check in object-oriented programming? Why it's considered bad practice, or just bad, period? It's like you're a bad person if you do it. Any idea? Why don't we do this constantly? Why isn't your code full of if instance of checks? Yes?
I think it bypasses the polymorphism of object orientation.
So the answer is it bypasses the polymorphism of object orientation. Yeah, but that's kind of like circular. You're right, it bypasses the polymorphism of object orientation. But why? Why does object orientation say that's the kind of polymorphism we don't want? So polymorphism only means that you have a function that takes or is available on a general type, and then it behaves differently for specific types. You all know this intuitively. If you call out a list.add, you know that an array list will do something vastly different from what a linked list will do, right? So that's classic polymorphism object-oriented programming. Add and linked list behave differently from add and array list. But you could implement it this way if you really wanted to. You could have like a static add method that takes the element and the array list and just does this, which I would not recommend, but you could.
You don't let the compiler do what it's supposed to do. You don't let the compiler do the type checking if you do the type checking at runtime.
So the compiler is supposed to do the type checking, and if I do the type check at runtime, I'm basically taking away that task from the compiler.
Taking away the task and the safety.
The safety, that's the good one. Exactly. It's about safety. Because it may not be future-proof, right? Like, what if I happen to add a new type? So let's go back to my crazy idea where I have like a static add method that takes the element and a list and then tries to figure out if it's an array list, do this. If it's a linked list, do that. What if somebody implements their own list type? Then, well, the behavior, first of all, is undefined. But also, how do I find out, even if I add another list type, how do I know that I have to change that line of code? The advantage, and that's also what object orientation buys us, is if I have a method or an interface that's called add, I cannot implement a type of that interface without having to implement that method. I mean, since we're talking about collections, I could always just throw an unsupported operation exception, I guess. But more seriously, so that's what the compiler gets us, right? The compiler tells us, look, you added a new type, you have to make sure that all operations work on that type. And likewise, if you add a new operation, you have to make sure that every type works with that operation. But the funny thing is, this one is future-proof. What we just built has exactly those properties. So let's just take this example. Let's say we figure out that actually GitHub also has a pages for commit. And now our system needs to scrape those pages and needs to be extended by those pages. So let's add this. And let's follow the compilers, right? Because that's what we use the compiler for, exactly. We want it to point us to all the places, so we kind of want to provoke a compile error to then follow it to all the places that we need to change. So if we say GitHub commit page implements page, then we get a compile error because page is sealed. So the first stop is we have to go to the sealed supertype, and we need to permit the new subtype. So we do that. We go here and say, okay, now we also have a GitHub commit page. Now we get compile errors everywhere where we did this. Because compiler will now tell us, well, all of these cases, you're not exhaustive anymore. You added a new type, you added a 5th implementation of page, and you didn't cover it. So now we have to go to each of these operations and add the missing branch. And that's exactly the behavior we want. We want to be able to have that adding a new type will not silently fall through an if-else-if instance of chain and then just lead to no behavior or even just a runtime exception. At compile time, we want to be called out and be led to all these places. Note that this only works without a default branch. If you have put a default branch there, it will still be exhaustive. So avoiding a default branch is important in these cases. Okay, I've just talked you through a lot of like practical things that work together in a specific way. Let's take a step back and talk a little bit about the general thing we're doing here, and that's called dynamic dispatch. Dynamic dispatch and polymorphism go hand in hand. Polymorphism means a function reacts differently to different types, and dynamic dispatch means, well, okay, now let's figure out which method is exactly the one that I need to call for this type. And the main way that we do this is with inheritance as a language feature, right? As again, you have list interface, you have an add method on that, and then every type has its different implementation. And at runtime, dynamic dispatch will mean, oh, you called add on a linked list. Or let's go to the linked list method body and let's execute that bytecode. And that makes that method part of the API. And that's great in, I don't know, 60 to 95% of the cases probably. But there are always situations where you don't want to make an operation part of the API. What do you do then? That's what the visitor pattern is there for. You want to have dynamic dispatch, but you don't want to have it to be part of the API. So you go through the visitor pattern, and what you get there is that you still get the same behavior, right? Adding a new type causes compile errors, you follow those compile errors, and then in the end, you covered all of those cases. But that makes visitation part of your API, and as I complained earlier, it's a little bit cumbersome, it's indirect, it's not easy to grok what exactly is going on. And what pattern matching does, it adds an alternative here and says, look, all you need to do is make sealed part of the type, and from there on, it's straightforward. So this combination of language features kind of like replaces that pattern. And that is not something that is uncommon. I'm not sure whether I subscribe to this interpretation personally. Like, it sounds good, but I don't know enough about that space to really make that decision. But many people say that design patterns make up for gaps in the language. You only need a design pattern if the language doesn't do it. And the first time I read this, it sounded weird to me. But I think it's pretty good, actually. It's like it feels very true. Like, again, I didn't look into this enough to make that decision for myself. But one thing where it feels like it really applies is with, for example, a strategy pattern in Java. Who knows the strategy pattern, like from the Gang of 4 books, and roughly knows what it does? That's about half, maybe. Okay, I'm just going to assume the other half was like, it's Monday morning, I get it. Strategy pattern means, so a type needs to have an action, a strategy passed in. So what it does, it creates an interface, often an interface with just one method, but could be arbitrarily many. It creates an interface like a listener, for example, and then you create all of the implementations, the actual behavior, and pass that implementation to that object that then takes your strategy for reacting to listeners or whatever and calls your code. That used to be a real thing, right? That used to be like, oh, I have this problem. I realize strategy pattern is the solution. You feel really good about yourself. You write all of that, and it's great. Like, you applied one of the Gang of 4 patterns. It's 10 a.m., but your work is done for the day. You go home. It's good day. Every time you pass a lambda in Java, you apply the strategy pattern. Who thinks that every time they type out a lambda, I'm like, yes, strategy pattern? Just me then. No, me neither. Like, it just goes away, right? It's not special anymore. It's just like I'm just applying a language feature. What are you talking about? And that's very common, right? The other languages, they don't even have some of the patterns that we need in an object-oriented world because they're just, well, just do the thing then. There's no pattern. Just apply the language. And this is what pattern matching does. Whether the rule is true in general that patterns only exist to make up gaps in the language, it is true with lambdas or method references and strategy pattern, and it does also apply to pattern matching a visitor pattern. Now you just use pattern matching instead of visitors. Good. So in case you felt icky earlier, every time you want to divorce operations from the type, you don't want to have the operations as part of the API. Every time you're in that situation, you now have a good and simple solution. How often that you want to do that applies a whole lot to your programming style, applies also a lot to the domain that you're working in. I worked in a code base that used a lot of visitors, which was very annoying, but was also just the good solution to do for the problem that they had. So, yeah. Also, visitor pattern is also not only about this kind of like the distinguishing by type, it's also often about navigating a more complex data structure. You could do that by exposing streams, although I didn't go into this here. I'm just talking about the language features that were new. Okay, so let's look a little bit about the practice. How would you apply records or switch or pattern matching in practice? And you can do this for ad hoc data structures, more complex return types, or even for complex domains. And I will give you an example for each. So one thing that you can use records for that were just amazing are for like throwaway types that you just need here in this, this one place, or maybe in this one package. So for example, while I'm building this page tree, I'm loading the page, but I also need to collect the links, right? I need to collect the outgoing links, and that needs to be mutable. So just to make sure that I have this, I combine an incomplete page object with a growing set of links in this record. And I went through a bit of extra trouble to make sure that the page is not null and that the links are not null and that I actually get the links as a mutable set instead of maybe a set.off. And that's just even extra work. But if you have this situation where I have this type and I also need this type together somehow, why doesn't Java have to have tuples? Records are nominal tuples, meaning they are tuples, but that you have to give them a name. You don't call this get1 and get2. You call this page with links dot page and page with links dot links because it very clearly tells you what's going on. So if you have the situation, we just need to throw a few pieces of data together for a stream pipeline maybe, you can have records as one-liners, no problem. You can do more complex return types. So for example, let's say you want to write a method that finds a user. So you give it a username. And what you get back as a match. And it's like, what's match? Like, okay, so I have these types here. Match is a sealed interface that permits all of these down here. And the possible implementations are none, exact match with none doesn't have any components. It's just empty. Exact says, well, I have the exact component you're looking for, and fuzzies contains a collection of the entities we were looking for, some like fuzzy matches if we didn't find any of the other. So I want to find a user. I have 3 possible outcomes, which is I didn't find anything. I didn't find exactly what you were looking for, and I found a few things that might be close. Go look for yourself. And instead of trying to combine all of that into like one type with flags and is exact Boolean methods or whatever, I do this. I use the type system for that. And this is what the code that operates on this method would look like. You would say, okay, find the user John Doe, switch over the result, and in case there is no match, do this. In case there's an exact match, do this. And in case there's a fuzzy match, do this. And I would claim that this is supremely readable. Like if you look at this piece of code, if you write it yourself, you're going to call find user, and then you're going to see, okay, there are 3 different subtypes. And you just explode the switch, and there goes your code into the right places. And if you read this, like I don't even, without the previous slide, even without knowing that there's like a sealed type involved, I would argue that most of us could read this and get the semantics. I'm trying to find a user, and in case I have an exact match, I do this and that. I would claim that is, as I said, like very readable. And so optional, by the way, could be implemented like this. Optional is implemented like that in many other languages, but optional was Java 8. Now we are 21. It's like 13 versions in between. So yeah. And you can use it to model more complex domains. Or with sealed types, with pattern matching, all that I just went through with page, that also works for parts that are integral to your domain. So it doesn't have to be just like short-lived return types or anything. You can expand this further. Talking about expanding this further, Java is also pushing this feature further, and pattern matching will see improvements. One thing that we already have is unnamed patterns. That's a preview feature in Java 21. We're going to go to that in a second. And then we have primitive types and patterns. So with already a JEP exists, which are crossing fingers to make it into 22. We may have deconstruction on assignment. If you don't know what that is, don't worry. It's coming. Links to a tweet from Brian Gates, which is the most official confirmation we have so far. And we're going to get a with expression, which is just amazing. Again, we don't have the time to look into this today. But if you're interested, go to the slides, go to this one. Everything that's green is a link here. So look at the design document. It's pretty cool. Now I want to talk at unnamed patterns for a moment. Everything I've shown you so far is a final feature in Java 21. You can use it. It's set in stone. Nothing's ever going to change again. Well, to the same degree as that is usually the case for Java language features. This is a preview feature, which means it might change. There is the JEP that wants to target this to 22 is already written, but it's not a final JEP yet. It's not a candidate. It's not implemented yet. And it says, we're just going to use it as is, no more changes. So unnamed patterns, still a preview feature, very unlikely to still change at this point, I want to say, but don't quote me on this, and don't sue me. Okay, so what I'm doing here is I'm using the underscore to ignore components. So let's say when I categorize the page, in case it's an issue page, I really only need the issue number. If it's a pull request page, I only need the pull request number. And if it's external error page, I only need the URL. So that's the idea here, right? I don't need all of those other thingies. Of course, I could just say case GitHub issue page issue, and then I get a new variable of this type. And then on the right-hand side of the arrow, I call issue.issue number. That would work. But you could also write it like this. You could say, look, let's ignore the first, second, and third components. I just want to have the, first, second, and fourth. I just want to have the third component, which is the issue. Give me that one as an int, and then I'm on my way. And what this does is it more clearly separates what do I need, which is now on the left-hand side, versus what do I do with it, which is on the right-hand side, which, is not on the slide. So you have a clear separation into those two parts, which I kind of appreciate. And you don't need to list all of these other components that I'm ignoring. But possibly more important is that you can now do this. You can use it to define default behavior. I said earlier how important it is to avoid a default branch. Let's say you have a method that's called categorize GitHub. You only want to categorize GitHub pages. So you do something for issue and pull request page. But if you have an error on an external page, you don't want to do anything. Now the switch wants you to be exhaustive. So you would be tempted to say, well, I'm just going to put a default branch there. But again, then we add the commit page. The commit page falls into the default branch silently. You don't get an error. Everything just works until it doesn't, because somebody's complaining that the GitHub commit pages are not categorized. So if you don't use a default branch, you somehow have to write case error page, do nothing, case external page, do nothing, or maybe you have like a similar kind of body for all of these, or the same body, and that's sad. What you can do with the underscore is put both of them on the same line. You can just say it's an error. In case it's an error page, I don't need the variable though. Or it's an external page, well, still, I don't need the variable. I don't care about the variables themselves. I just want to say, in case it's one of these two types, that's the branch that you're going to execute. And if you are using this feature, either as a preview on 21 or once it's final in hopefully 22 or whatever version you switch to where it's final in, this would be the way to go to avoid default branches. If you have defaulty behavior that applies to a few leftover branches, do it that way. Okay, so to summarize the pattern matching part. When you want to keep functionality separate from types, you want to seal the super type, you want to switch over that type, then you need to enumerate all subtypes and define what exactly happens in each case, and you want to avoid default branches for that. And if you're interested in more, the pattern matching in the Java object model is a document from Brian Getz that I can highly recommend. I made a video about this on the Java YouTube channel, and the GitHub crawler app that I mentioned earlier is there as well for you to experiment with. So, any questions about any of this? Let me see. I think no, I hope I don't miss anything. I'm going to give you a minute. Okay, I hope I don't miss anything. Didn't see anybody. Let's go on. Let's talk about data-oriented programming. So what I just showed you is a bunch of language features working together to do this pattern matching thing. What we're now going to do is we're going to take that and we're going to lift it into a programming paradigm where we say, yeah, this is really cool, but what if we did nothing else? Basically, right? What everybody did when stream pipelines came around. It's like, okay, no more for loops. Just like everything is a stream pipeline now. Just me? Okay. So every programming paradigm comes with a kind of everything is a sentence, right? And the goal of a programming paradigm is to manage complexity. And while some paradigms are just better than others, like for example, nobody would claim that unstructured programming, before structured programming came around, which said, maybe instead of a sea of statements with go-tos between, we have something like methods with entry points and exit points. Few people would be like, no, that's actually worse. We should go back to unstructured programming. Generally speaking, modern programming paradigms are so refined that none of them is clearly better than the other. Functional programming, object-oriented programming, great example. They have both their strengths and weaknesses, and often you will find situations where, in this situation, the one is better, and then there's like a dual of the situation. We're going to see a little bit of that in the small later, where then the other one turns out to be better. So they try to manage complexity, but because complexity comes in many forms, it depends on what kinds of complexity you're expecting. And whenever you hear somebody say it depends, well, if they're a friend, just, let it sit. But if it's a person that you want to prod a bit, or maybe it's somebody you pay, ask them on what, though? Because you can always say it depends. It's always the correct answer. You need to ask those people, what does it depend on? So I can make a decision that in my situation, those factors apply more than these. And so, if it depends on that a lot, I'm going to avoid that maybe. So that they can tell you what the shape of this it depends is. And I'm going to try to do that. As an example, let's talk about object-oriented programming, where everything is an object, right? That's the everything sentence. We try to combine, we do combine state and behavior a lot, mutable state specifically, which is a lot of fun. The whole thing hinges on encapsulation, and it uses polymorphism through inheritance, right? So to react differently to different kinds of types, you use polymorphism to express that. And encapsulation is very important because since all this state is very mutable, the least thing you want to do is avoid everybody doing it all across the system. And this works great when you have to define or uphold boundaries, whether it's boundaries between different projects, right? Like between different dependencies, or whether it's boundaries across different versions. It might be security boundaries. There's so many kinds of boundaries, and object orientation helps really well with upholding these. So if you need those boundaries, or if you need them to modularize a large program and a large problem, I'm not speaking about modularize in the sense of Java modules necessarily, but just the concept of I have a large problem, but I can cut it into distinct problems that have very little to do with one another and hopefully have well-defined contact points, and everything else is just internal to that problem, and then we can focus on that only. And that's basically what you're doing this. You're having a strong boundary that says, between these two problems, there are these well-defined contact points, but everything else is separated by a boundary, and that's why I can focus on one of them. I want to talk to you about a more data-oriented approach, and specifically for us, object-oriented programmers, those work better in smaller systems, and they work specifically well in systems that are focused on data. A small system does not have to be like an overall small system. It could be, for example, a small microservice if you think about it that way, or if you have a monolith, it could just be a small part in a monolith that does a specific task and has maybe like just one interface and a handful of methods that communicate to the rest of the app, and you're just doing this one, JSON processing down there, which is, obviously focused on data. So in the article Data-Oriented Programming in Java, Brian Getz put forward these guiding principles. Model the data, the whole data, nothing but the data. Data is immutable. Validate at the boundary and make illegal states unrepresentable. And I could leave it at that, but that doesn't give you so much information. So let's now apply this to the GitHub crawler that I mentioned before. So the app we just looked at is kind of small. It really focuses on data. It's about getting data from GitHub to create these instances. And then, using all kinds of weird features that I didn't implement yet on that type. And we do want to separate operations from types because we don't want to have the page type, be like the Kraken in this dependency graph. So this is perfect for data-oriented programming. So let's apply it. Model the data, the whole data, nothing but the data. Let's start at the beginning, and we're modeling the data. We know that we have 4 kinds of pages. We have an error page, external page, GitHub. That's what I set out saying, right? That's like our basic distinction. Okay, so let's just use 4 records to model them. This is what they would look like. Nothing special here. It's just like the error page has a URL and exception, and the external page has URL and content, and blah, blah, blah. You will see that the body is always empty. In real life, you would probably put a lot of stuff into, not a lot, but some stuff into the body. Specifically, things into the constructor. We'll see that in a second. But for now, that's the 4 records we create because they match closely to the data that we have at hand. But if we model the whole data, not just the data, you will notice that there are additional relationships that we kind of ignored so far. So we have these 4 types, but they're not all entirely unrelated. So for example, if I try to load a page, it will either work or it won't. And if it doesn't work, I get this error page. But if it does work, should I get something else? I get like some of the other 3. Okay, let's say it did work. Either it's an external page or it's a GitHub page. And if it's a GitHub page, it's a pull request on issue. And we can use sealed types to model these alternatives. So I use sealed types much more detailed than before. Earlier, I only used it to say, well, page has only these 4 subtypes. That works great with pattern matching. But now I'm coming from the domain side of things, and I will say, well, look, these are they're clear alternatives. For example, let's say we have another data structure that owns a page. And then we know, well, if you own a page, it must be, as I said, successful or not. It must be, if it's successful, external or GitHub. And we can express this with these sealed interfaces, which has page at the top, then successful page here in kind of the middle, which allows an external page or GitHub page, and then GitHub page is close to the bottom. And I gave you a diagram here. This is classic UML, where blue is interfaces and orange is records. But yeah, you will see that the records fit in quite nicely here. The page describes a URL getter. I didn't write get URL, but a URL accessor. And then if error page has, as you can see here, here has this component URL, then this component URL spawns an accessor URL, opening, closing parentheses, which works great with this interface. So that's why this all works out neatly. And what we can see here now is what I just mentioned in words earlier. If I have a page, I must have one of these subtypes. There's just no other possible way because everything is sealed or final. And what this gives us, records to aggregate data and sealed types to express alternatives, is what the fancier people call algebraic data types. Records are called product types. Seals are sum types. No, sorry, they're not called that. That's wrong. There's a concept of product type, and in Java they're called records. There's a concept of sum types, and in Java they are called sealed types. And this simple combination of mechanisms, aggregation and choice, is very powerful. You can model a lot of things quite cleanly with that. If you want to know what product types or sum types mean, raise your hand and ask me, find me in the break or after. I'm here for the whole rest of the week, but let's skip past it for now so we get more Java down. Okay, let's keep going with data-oriented programming. Next step was, one of the other things that was mentioned was making legal states unrepresentable. We want to make sure that things that do not happen in the domain cannot happen in our code. And many of these things already don't work. So for example, there's no way for me to have an error from I could not connect to a page, and also to have the content of a page in the same type. That wouldn't make sense, right? Either if it's an error, I didn't get any content, and the other way around. So this combination should not be possible. And because we cut the types very closely to what the domain gives us in information, this combination is not possible. If you try a simpler approach, a more classic and not very somewhat naive object-oriented approach, you could just have a class page that has an error field and a content field and an issue number field and a pull request number field, and then you have to figure out at runtime which of these it is. So if you cut these records very closely to what the domain prescribes, many of these illegal states will already become unrepresentable, and everything else you validate at the boundary, which is where the constructors come in. So if you haven't written records before, I've already used this syntax before, but that might have been slightly confusing. Let me explain it now. Again, I have a record definition here, and then in there, I have a constructor. But this is what's called a compact constructor. There are two things different. One of them is that I do not have to list out the parameters, because in all likelihood, in usual Java code, there should be 2 lines above. Right? So you should always have the compact constructor at the top of the file. It's just the same thing again, which means if I add components here, I don't have to change this line. It's a little bit cleaner. What the compact constructor, so that's the one difference. I don't have to list the parameters. The other difference is I don't have to assign to the fields. That happens automatically after the body of the constructor. So really everything that goes into the compact constructor is any non-obvious behavior, which is anything I want to check at all. And that's in this case is I want to make sure that UL is not null, content is not null, and also content is not blank. That's what I use these checks for. You don't have to use a compact constructor. If that makes it look weird, you can just put the regular constructor there. Okay, so validation at the boundary means the constructor, or maybe a factory method if it's more complex, that you have there should make absolutely sure that the data you're creating is already in a valid state. Compare that to Java Beans, which are usually the other way around. We're just like, yeah, no, sure, create me in a broken state, then call a bunch of setters, and then eventually, if we're so invested, maybe we have a method at the end of all of these setters that check whether the combination of data you set makes sense or not. But if I forget to implement that method, or you forget to call this method, and you have a Java bean which is this random combination of data which we are not sure whether they even should exist or whether they even do exist in real life. So this makes sure that once you have a Java object, it mirrors a correct, like it is a correct representation of reality. Data-oriented programming also hinges on immutability. Records are shallowly immutable, which means you cannot reassign the fields. But if you have a record that has a list and you give it an array list, I mean, like a record that has like list of string names as a component, then if you call the constructor with an array list of string, then of course that array list is still mutable. So you cannot reassign a new list to that record component, but records are not magic. They cannot just sprinkle immutability dust over our code base, and then suddenly these other Java types that have always been mutable become immutable. That's not how it works, unfortunately. So if you do actually want to have immutable types, specifically with collections, that's the most common occurrence, but also elsewhere, you have to somehow fix that during construction. What I do here, for example, for the GitHub pull request page, if you give me a link, a set of links, I will use the set.copyof method that creates an immutable copy of it and assign that to the constructor parameter, which would then later get assigned to the field, sorry, singular. So yeah, again, this should be the default, that you make sure that everything is deeply immutable in a record. But you've also seen me already abuse this earlier on a slide where I had this page with links. I was like, no, I actually do want the set to be mutable, so I can change it because I still need to gather some data. That's fine. Like, it's not like you cannot use mutability with records, but immutability should be the default. Okay, so where are we? Let's catch our breath for a moment. We made the page type explicit in Java's type with these 4 records and all those sealed types. We made sure that only legal combination of data are possible, specifically combinations of fields, but also we validated everything that came in at the boundary. I would claim that the API is pretty self-documenting. You've seen the small inheritance tree there. On every level, that all makes a lot of sense. This code that I showed you so far is trivial to test. You probably don't even really want to test it. The only code that really happens is inside the constructor for some null checks. So this is all good. But where did the operations go, right? We just talked about types. And the idea here is, and this is what I fought Brian for these 4 guidelines, principles. I think this one is way too implicit. I was like, where in those 4 principles does it say that the operations should go elsewhere? It's like, well, it's in the nothing but the data part. Okay, that seems like shoehorned in, but okay. So the idea here is on the nothing but the data part is that operations are not data. So they should not be part of those types. They should go elsewhere. What is entirely okay if I have stuff that uses derived quantities. So let's say I have this record for GitHub issue page, which has URL and the content and an issue number and the links. And then I want to create like a pretty string, which uses the cat emoji and the issue number, right? So this is not the toString method. I intentionally want to have a toPretty string, I don't know, presented in a UI or something. So sure, that goes here, right? That only uses local fields. That's fine. I'm not saying records shouldn't have methods. I'm saying records shouldn't have methods that take in other objects and operate on or with them. Instead, we should define them elsewhere. So they're usually going to other subsystems, and we've already seen this before. We use pattern matching over sealed types to model polymorphic operations. We do avoid default branches, and we use the record patterns to access data. And this is just pattern matching. I gave you another example here. So let's say toPretty string, for whatever reason, is not on the type. What would it look like? Again, you have a method. This one is even static, that gets the instance. So instead of calling page toPretty string, you're now calling toPretty string with page. It switches over that, and then it says, look, I'm just taking this, I'm looking through the 4 possibilities that I have, I'm taking them apart as I need them with record patterns, and then I return the result there. It's very important that if you do model data, that you do use records for that, because of that transparency, right? This stuff, taking them apart, only works with transparency. if they would hide their internals, if you use a regular class and do not expose all of the data to accesses like this, then I cannot write my operations outside of these types. If for my operation on the GitHub issue page, I need the issue number, but you use a class and you don't expose the issue number, then I cannot implement my operation. That's why these things go hand in hand, right? The transparency of a record makes it possible to take it apart into everything that it has, and that makes it possible to implement operations from the outside. Okay. Some of you may have been screaming internally. Oh yeah, Mario.
Just an observation. Okay, we don't have this in Java, but the only difference here is that you are passing the page argument instead of calling page dot something, and it will be nice, you know, with extension. Yeah.
Yeah, right. So that's actually an interesting one. Okay, let's say I wrote this, and now I have to call toPrettyString with page. And you can already see that you could just call page.toPrettyString and do like a switcheroo and then redirect to this method, right? That's, you know, other languages do that. It's called an extension method. What that means is I can provide static methods that take arguments, but the compiler will give me a fiction, which is I can take the first argument and call the method on that. And then the compiler will realize, wait, page doesn't have a toPrettyString, but there's a toPrettyString over there. And if I put page as the first argument, then it all works out. So yeah, extension methods are not in Java. Brian Getz is not a fan, and he has a thumb on this scale specifically. So I know his reasoning is that it becomes harder to read code locally, because now you do not know, if you don't have an idea around, where this method exists and where it comes from. It might trick you into believing that this is part of the types API. That's my best rendition of his argument. He has sessions here, so feel free to poke him for more details. So again, if you've been looking at this, you might have been screaming internally, well, dude, you're talking about immutable data structures, about methods. You didn't say functions, but clearly you meant functions operating on them. Isn't this just functional programming? Yeah. Like, yes, you wouldn't be wrong. Shouldn't be screaming, but you wouldn't be wrong. Functional programming says everything is a function. You focus on creating and composing functions. So if that's like the main goal. And data-oriented programming says, no, let's focus on the data the most. But in most situations, it will still get you similar results. Right? Like if you model a system based on separating functions from operations, and then you're designing both of them to work as best together as you can, you might run into situations where it's like, this is the more composable function, but then this data is a little bit awkward, and functional programming would be more inclined to tell you, yes, lean on the side of composable functions, and data-oriented programming will tell you, no, lean on the side of modeling the data perfectly. But that's just a nuance, right? So if object-oriented programming is here and functional programming is here, data-oriented programming is much closer over here. So that's very similar. And that also means you can absolutely write entire large systems with data-oriented programming, because people have been doing this with functional programming as well. So when I say use this in smaller subsystems, it's mostly meant for us object-oriented programmers who might not feel so great about separating functions and operations across millions of lines of code. I'm also not here to tell you that object-oriented programming is dead. It has been declared dead a whole lot. Much like Java, what is dead may never die. It's still very valuable to model complex entities or rich libraries whenever you need encapsulation. And it's a good default for those of us used to that thinking, to use that on a high level and modularize larger problems into smaller problems. But once you reached small problems that are small enough to keep in your head entirely or mostly, when this strict boundaries are not that necessary anymore, because they do come at a cost, right? Or when you're working a lot with outside data, where you just like get some data in, you just transform it and you send it out again, which is an apt description of actually surprisingly many Java apps, right? Like like a simple CRUD app is just connecting JSON with SQL, really. So you can see how that factors in there, how that could be modeled this way. And specifically in a situation where you feel like the data and the operations working on them should be separated. In those situations, consider giving this a try. So I've written the GitHub crawler like this, because I need a demo app and I want to familiarize myself with the concept. Since then, I have 2 other projects just like small demo projects, right? I don't code for production environments anymore. Well, that's actually not true. I did a little bit for the Java playground. What I'm saying is, anyway, like it's smaller projects, mostly just me working on them. So take this with a grain of salt. It's surely not representative. But in the short time span since I wrote the GitHub crawler a year ago, I already had 2 other code bases where this just popped up as like the natural good solution. Not because I wanted to try it, not because I want to shoehorn it in, just because there was a part that was it's just 5 types modeling 5 things in reality, and all I need is to operate a little bit on them. And it's just a package even in a larger system, but just using it there really made a lot of sense. So I think once you have that in mind, there's a good chance you're going to end up using it. Okay, so data-oriented programming in a nutshell. Use Java strong typing to model data as data. Specifically, use records for data as data, and use sealed classes for alternatives. Then separately, you have your methods, functions, that model behavior, and there you will use an exhaustive switch without default branches to figure out which specific implementation you have. And then you use record patterns to destructure the data and then pull out what you need. The guiding principles from Brian again: model the data, the whole data, nothing but the data. It should be immutable, validate everything at the boundary, and make illegal states unrepresentable, so that whatever is in your system is valid and okay to be processed. More on this is in the link of the article to Brian. Again, the same video, Java 21 brings full pattern matching, but there's also a video specifically on data-oriented programming. And again, the GitHub crawler, the other half of it, is the Loom part, but the data-oriented part is all there. Okay, so we have been here for what, like 55 minutes? 65 minutes. I would want to take 2 shorter breaks, but I'm afraid with so many people in the room, it will take a while to filter out. So why don't we take a 24-minute break and meet again at 11? Is that okay for everybody? Good. Okay, so I'll see you again at 11, and then we're going to go into virtual threads. Okay, let's talk about threads. Virtual threads specifically. Hope you all had a good break. I had a few people down here asking me questions. I'll be here after the session is over. Can I be? I think the next one starts an hour later, right? Okay, so you can come down here, you can ask me whatever you want. We have an hour before we get kicked out, and then we can stay out there in the hallway for the rest of the day if you're interested. So please come here and ask questions. I'd love to answer them. Okay, let's talk about something else entirely. Pattern matching has been something that is very kind of like cool. You can start using that in the small. You can start using it to redesign your entire system. It's a lot of thing to work with. It gives you a lot of matter to work with, right? Just like Lambdas did, for example. Virtual threads are not like that at all. If you never ever instantiate a virtual thread, like specifically not, if you don't explicitly ever create a virtual thread, the feature might still work perfectly for you, right? Just like nowadays, you don't spend a lot of time in code that, creates threads or, handles stuff over to thread pools. Most of you at least don't. The same will apply to virtual threads, right? So don't expect this to be the kind of, oh, I can, play with this here and there. I will show you how it works, and there can be a few things that you can do to prepare. But mostly, this will be something that happens just outside your site, within your web framework, within the runtime. Okay, but let's go over this. Let's talk about a simple web request that comes in over HTTP, probably some JSON. I have to interpret that, figure out what's wanted, probably create some Java objects, and then at some point I ask the database, and I wait. And then the database sends back, and then I do the same in reverse. I go through the database response, pull out the information I need, maybe some Java code runs to do some checks or whatever, and then eventually I put it into JSON and send it back out. How's the resource utilization? It's great for step 1 and 3. Everything is busy, CPU is busy, memory is busy, everybody's doing something. And in step 2, I'm doing, at least the runtime, as far as the Java runtime is concerned, I do nothing. I just sit there and wait. And how could we implement that? And there are 2 approaches to this. Clearly, the app wants me to do things at the same time. It wants me to do things concurrently. So the unit of concurrency of the app is different requests happening at the same time. The unit of concurrency within the runtime is threads. So the obvious solution would be to have 1 thread for each request. So that's great. It's simple to write. Try with resources blocks, profilers, debugging, stepping through all the functions. Everything just works as expected, and that's great. But it blocks on some calls, right? Like when we access the database, we're blocking that thread. And that can become a problem. And that can not only become a bit of a problem for some applications, it can also become a huge problem for quite many applications, actually. If you have highly concurrent things going on that don't require a lot of processing on your end, and you could have tens of thousands, hundreds of thousands of these requests handled concurrently, you would need tens of thousands, hundreds of thousands, maybe millions of threads. The problem is that a regular Java thread, which I will start calling platform threads from here on out, is just a thin wrapper around an operating system thread, which has, I think, like 1 to 2 megabytes of overhead. It's not trivial to create. The switching cost is not exactly cheap, but it has, as I said, like, it requires memory. And if you think you're going to have 1 million, and each of them takes a megabyte, that would be a terabyte of RAM, which is just threads. Like, you didn't even do any computation. You didn't even store any information in memory yet. It's just a terabyte for the threads, which is clearly going to be a bottleneck at some point, probably actually way before the terabyte for most people. So what you end up with is bad resource utilization. You've used all your memory, but only because you need it for the threads. Otherwise, you know, there would still be plenty of space. CPU is not doing so much. Network and file system, maybe somebody, you know, the database over there is busy, but you're blocking that. You have this expensive resource there that you're holding on to, and that can lead to low throughput. So some people had quite a good idea, which was, you know what, if that resource is expensive, maybe we shouldn't just let it lie around. Like maybe we only use it if we actually need it. And the idea behind that is that you use non-blocking APIs, like in Java that would be a completable future, like, you know, the class completable future, or reactive streams if you want to go all in. And you cut and piecemeal all your tasks into things that you can pass in these reactive streams, and then they do the thread handling, and they make sure that you only use a thread when you actually need it, which is a pretty good idea. That code is harder to write, although sometimes people tell me, I think in an audience this size, there will probably be a few people here that say, no, I actually kind of like the reactive APIs. I like the way they make me think about solving a problem with these predefined building blocks, much like I like using the Stream API for that reason, because it has, you know, I mean, there are many building blocks, but mostly a dozen of them are enough to model like 95% of the for loops. And it's great, right? So I can see, I don't have to figure out again and again what this loop does. It's just like, okay, it uses these building blocks, I get it now. And some people tell me that they like this in reactive streams too. Not that many, but some do. I never found anybody who's like, no, debugging reactive stream pipelines is super fun. I prefer that. I guess everybody who laughed just now was like, yeah, I've done this. I don't like it either. Another problem is it's incompatible with synchronous code. So if one of your dependencies doesn't know like the tricky thing that you're doing, it just starts blocking threads, that's bad. But if everything works out, you can share platform threads much more widely. You can have much better resource utilization, and that can give you really high throughput. This can give you the scalability up to, you know, doing 1 million things at the same time, even though those will not be 1 million threads. So you see a conflict here. A conflict between writing simple code and getting the throughput or the scalability that we want. And on a side note, so this is what Project Loom, which gave us virtual threads, is concerned about with this conflict. And you can take this lens of there's a conflict deep within the Java platform. You can take this lens and view other projects through that. This is just a sidetrack. It's not important for the virtual threads part. But I think it's very interesting. Project Valhalla, which wants to give us value types, wants to resolve the conflict between using the design that you want and getting the performance that you need, or at least you think you need. Amber wants to resolve the conflict between everything having to be explicit in Java's type specifically, but more generally, everything has to be written out, which is good in one sense, but sometimes you just want to have succinctness. Maybe you don't want to write user, new user. Right? Maybe at least one of those 3 users is superfluous. Panama wants to resolve the conflict between the flexibility that unsafes give you and the safety that the non-unsafe APIs give you. And Leiden wants to resolve the conflict between all kinds of optimizations that we want to apply, but that may conflict with the Java specification, and to find a way to get both of these worlds. And so this is something that many of the larger projects are concerned with if you want to, as again, see it through this lens. And that also explains why not every idea that somebody might have gets their own OpenJDK project, because these are usually concerned with like deep-seated issues and not just surface-level polishing. Okay, anyway, let's go back to virtual threads. We were in this conflict between simplicity and throughput, and they promised to give us both. A virtual thread is a regular thread, and you've seen, oh, there we go. You've seen my talk for long enough to know that this weird font here is the code font. What I'm trying to say here is it's an instance of the Java class thread. That's how much a virtual thread is like a normal thread. It's an instance of the, well, it's a subclass, but still. Has super low memory footprint, very small switching cost, and it's scheduled by the Java runtime instead of the operating system. But the most important part is, while a virtual thread is waiting, it does not require an operating system thread. So while it's busy, it does. But when it's waiting, it doesn't. Which makes sense, right? When you have to do computation, you actually do need the thread to do the computation. But if when the virtual thread is waiting, it doesn't need one of these expensive resources. Now you might be curious, how does that work? And we're going to get to that a little later. Because it's interesting and also gives you some insight, but it's important that you understand that we don't really need to know this. Like, who of you studied computer science? Who of you learned how virtual memory works? Who of you remembers how virtual memory works? Excellent. Wow. do you need this? Okay, wow. That's not fair. It's his job, he said. Right, so my point is, virtual memory says, well, look, let's imagine we had these terabytes of, well, not terabytes, but let's imagine we have this like dozens of gigabytes of memory, go have fun. And all the apps are kind of happy with that. And when you write an app, you usually don't care that that's not actually true. That's an illusion. There is not that much memory. But it kind of works because not everybody uses all the memory at the same time. So, the illusion gets us very far. And the best way to view virtual threads is like that. Virtual threads map a large number of virtual threads to a small number of operating system threads with some magic. And they give us the illusion of plentiful threads. And you know what? If we didn't have 3 hours, I could end it here and be like, that's all you need to know. Go use virtual threads. Because that is all you need to know. We're going to look into more details, mostly for fun. But that's the important takeaway. Virtual threads, the implementation details are not that essential to know. Right, so programs rarely care about virtual versus physical memory. And just the same way, you wouldn't usually care between virtual and platform threads. Just write straightforward blocking code. And then the runtime will somehow share the available operating system threads around. And the cost of blocking for that database request I mentioned earlier is near enough to 0, so that you can do whatever you want. One of the things you want to do maybe is create 1 million threads. Crazy. Okay, let's do this. So I used an executor here, which is a new virtual thread per task executor, which is quite the mouthful. What it says on the tin, though. Every time you give a task to this executor, it will just spawn a new virtual thread. It does no pooling, nothing. It's just everything is a thread now. So I create 1 million threads, and I have to reassign that variable to number here very annoyingly because I'm going to use it here. So we're going to sleep for a second, and then return the number as a result. So what I'm doing is I'm creating 1 million threads that sleep for a second. Now, I was under the impression that this doesn't take much longer than a second on this laptop, but I recently tried this again, and it does. Not sure who's at fault here, but it still only takes like 6 seconds, and that includes the compilation of that code. So like the overhead is not big, right? So basically for 1 million threads to wait for a second, there is apparently some overhead to create like 1 million of them. Virtual threads, that is. But if you do this with platform threads and you create 1 million of them, you're going to crash something, probably, or you're going to wait a long time. Okay, so 1 million threads, no problems, you can just have those. So virtual threads remove the number of threads as a bottleneck. And you can use the app's unit of concurrency, which is in this case requests, and use Java's model of concurrency, which is a unit of concurrency, which is threads, and have a one-to-one separation. Now you can have simplicity and throughput. So I just told you that, look, we can have 1 million, and here it says removes the number of threads as a bottleneck. So Ron Pressler, who worked on this, said something very interesting. And so the question comes up, how many threads can I have? And at some point he started to answer, that's the wrong question to ask. Let's say your task is to map user IDs to usernames. And it's a map from string to user or whatever. How many entries can you have in that map? Well, hopefully enough that you can actually model your domain, right? You don't count the number of strings that you can have out beforehand. You just hope that you implement your business logic and it just all fits. And that's how you should think about virtual threads. Every task that needs to happen concurrently now is naturally a virtual thread. and then you, just like with the map example, you cross your fingers and you hope that it all works out. That's just how we usually do with Java development, right? We just use the systems that are there and then rely on those systems to keep working until they very explicitly tell us that they stop. And then we start thinking about them. And that's the case here as well. So don't think about how many threads can I have. Just think about this is a concurrent task, so it becomes a virtual thread, and there you go. Okay, so virtual threads also very important. I have to say that they are not faster threads, right? It's not like you can finish anything sooner, really. Like every task takes the same amount of time, the same latency. There's one caveat where it could become faster, but generally, let's just say there's the same time. So why do we bother about this? Like, why are we talking about this when the performance is the same? Well, performance it's a very complicated thing to look at. And here I said it's the same latency. But what we care about is throughput. And I brought this handy table for you, which is based on an article written by Ron Pressler, which I'm going to link on the slides later, where he distinguished parallelism from concurrency. I don't think that that's a universally established distinction, but it's definitely one that helped me a lot to understand this better. So parallelism and concurrency, let's quickly talk about what those things are. Parallelism is when you have a big problem and you want to solve it faster, less wall clock time. So you split it up into smaller problems, give these smaller problems to many different CPUs, and once they're all done, you combine it to a big solution. So that means as part of your solution, you create different tasks. It's under your control. Resource use is coordinated because you have control over that, right? And you do all of this to reduce the latency. That's what you're trying to do here. It's going to cost you more resources than doing this regularly, right? Like if you have, if you have to solve some big problem that you then split into 16 small ones to run on 16 CPU cores, the total CPU time will be larger than if you just let it sit on one CPU for the entire time. You don't care about resource use here. You care about reducing the amount of reducing the amount of wall clock time that it takes, not total computation time. And your abstraction is usually in the area of like, well, if I have 32 cores, I'm not going to split this problem into 32,000 sub-problems. Usually, I think there are like problems where that works, but that's the exception. Usually, you just are in the ballpark of 32 with your split. Concurrency is a whole different beast. In concurrency, the fact that things have to happen at the same time is not under your control. It comes from the outside world. The outside world tells you, no, but I have another request and another request and another request. So the environment is throwing that at you, and you have much less influence over it. The resource use is competitive. And what you care about here is just to get as many of them done at the same time as possible, right? In a fixed amount of time, you just want to get as many of them done. So that would be the metric here is throughput. And ideally, you want to be able to just use as many threads as you have problems. Right? If the exterior world throws 1 million requests at you per second, ideally you want to be able to just create 1 million threads per second. Okay, so virtual threads are in the right column. Hands down, that's the important part, right? Like if you in the parallelism column, you probably don't want to look into virtual threads. You probably want to use regular thread pools, platform threads, all of that stuff, right? Virtual threads are there for situations where you have high concurrency and where you are not CPU bound. Because when workload is not CPU bound, you're waiting for external systems, and you usually want to wait for as many of them and as early as them as possible, and that's how virtual threads increase throughput. Just because you can pull in, I don't know, another 100,000 requests immediately and have all of them start waiting for the file system, the other services, the database, whatever. So consider virtual threads when workload is not CPU bound and when the number of concurrent tasks is high. This also tells you that while with virtual threads, maybe your app could see a potential 10x improvement in throughput, the next bottleneck might just be around the corner, right? Maybe you're asking the file system or the database stuff, and maybe they can only take 20% more calls before their bottleneck, right? And so you don't get 10x, you just get 1.2x, which is what usually happens in performance improvements. You clear one bottleneck, and then the next one becomes obvious. So it's also important to keep in mind here. So if you're writing not a server from scratch, but just like a regular Java backend, you probably have a framework or a web server that handles your, so you will request thread spawning for you. And you will have to tell them to give you virtual threads. And we're getting there. So Spring Boot, for example, in November, they're planning to release 3.2. And they can just say Spring Threads virtual enabled to true. And there you go. Now you have every request as a virtual thread. I always link to the sources here, which usually isn't documentation yet, but some blog post. Quarkus does it a little bit differently. I couldn't figure out on which 3-point-something version it works. Like, it works on the newest version, but I think it has been around for a couple months now, so maybe it works on 3.2. I don't know, like 3.4 definitely works. And there you have a run on virtual thread annotation that you put on the handler. So you can have one handler being a virtual thread and the next one not, which is, okay, different way to do it. Halidon is super interesting in that regard. Halidon had a project Nima where they just re-implemented the entire internal server based on virtual threads, and that's just what they do now. So you just use virtual threads by default. On Halidon 4.0 at least, the first release candidate has been released soon. And yeah, there's a little bit more here that you want to go into, and now you can go forth and multiply your threads. That's all you really needed to know. All you need to do is like tell your web framework to do it for you, and there you go. Have fun. We are going to look under the hood now, but before we go there, I want to ask, do you have any questions about this? Let me check. Yep, looks good here too. Yes?
When would you still go to reactive programming when you have virtual threads available?
Okay, so the question is, when you have virtual threads available, when would you still do reactive programming? I probably won't. So I think the main reason to still use reactive is if you like that way of writing and debugging or profiling the code. So if you think like these building blocks are something that I have a good reason to use, that's a big one. Another one will be that the performance characteristics of virtual threads and reactive streams are not identical. Memory consumption or like how fast like concurrent tasks, I think like how fast you can start having more tasks. I think just the overall throughput. There are differences in details, and I think the community and ecosystem is currently trying to figure those out. There's the first benchmarks start to appear, and I think it becomes important for large companies or large projects that switch from one to the other, or that maybe have one service that is reactive and a new one that's virtual threads that are comparable, to publish those numbers to give people information. So another possibility I see is, in this specific circumstances, I don't know, virtual threads have the same throughput but 10% more memory. Whereas in others, maybe they have 10% less. I'm making up these numbers, right? I'm just saying the performance characteristics might be different kinds of load. And if you know I'm on that kind of load and I need those last percent, maybe that would be another reason to stay there. But I think both of those reasons are kind of niche. So I think reactive programming is very important to keep Java present in spaces where it would have been long been pushed out. But if we see from other languages that have a different way or more handily available way to use something like this kind of reactive approach, like async await keywords, for example, or Go routines, those languages start to eat into Java because reactive is not everybody's cup of tea. And what virtual threads allow Java is to have, I think, one of maybe the best way to handle this kind of stuff, which is just write the code you want to write, and the runtime does the magic under the hood. So I think there will be very few reasons, the reasons will apply to very few projects to stay on reactive. That said, I wouldn't go around and tell people like, no, refactor, like entire app that is working, spend months of refactoring that to virtual threads for maybe no gain, maybe a little gain, maybe even a little loss. Don't do that either. If your project is working with reactive and it's working fine for you, just keep doing that. Whenever a new project starts, that's when you want to ask yourself, which way do I go? And I think the next one should probably be virtual threads for you so you can figure it out and learn how it works. And then you have a basis of data to compare and say, for the next one after that, I know both approaches now, I know their trade-offs. Okay, let's look a little bit under the hood. Let's talk about how you can prepare some of your code. I want to tell you, we'll tell you this later again. I'm going to show you some caveats and some ifs and whens. You might have heard some things out there about synchronization. Everything works correctly. And if it doesn't work correctly, it's a bug that needs to be fixed and will be fixed ASAP. So whatever I show you now, it's not about correctness. Your code will work correctly in virtual threads. It's all about how well can that scale. And some changes that you can make, you don't have to, but can make, can improve scalability, and also I think overall most of them make the code better. So first one, don't use thread pools for concurrency. Again, if you use thread pools for parallelizing a problem, that's okay. But don't pool virtual threads for concurrency. You only pool expensive resources, and virtual threads aren't one of them. Sometimes you use thread pools to block access to a system, to say like only 16 people can do this at the same time. Don't use thread pools for that. So this would be one way to do this. And I know it's a stupid example. I figured it out once I put it on the slide, but I didn't change it yet because databases have JDBC drivers have internal thread pools. And so they kind of do this already, right? Let's ignore that. Let's say for whatever reason, you want to make sure that only 16 people can submit a query to the database at the same time. And one way to do this would be to have a pool of threads that you set to a specific size, and then you query the database and you submit this task to this pool, and then you return a future. That would be one way to do this. Again, don't pool virtual threads, move away from this. This thread pool is not needed. We have actually things in the Java API that is there for limit the amount of concurrent access. For example, a semaphore. So use a semaphore instead. That's also limited to 16, and then acquire the semaphore, do your thing, and then release the semaphore. Because this is the construct that is meant to say this can only happen n times concurrently. What this also does, look at the return type. Now it no longer returns a future of t, it returns t itself. Because this call is now blocking. This call is not blocking. You call query database, you immediately get a future back. You're not waiting in between. This one blocks, which doesn't matter. It's a virtual thread. Who cares? You call this thing, and then when you get your result, the code continues. Right, so the virtual threads aren't like they have already been created elsewhere. Actually, the later is wrong. Like this, the virtual threads have been created outside of this. I need to remove that line. Okay, so that was one important thing. Don't pool virtual threads. Now, let's go over a few caveats. And for that, we need to understand how virtual threads actually work under the hood. And as I said, it's also kind of interesting. So how does the runtime manage it? So there is a pool of actual, down-to-earth platform threads. We call them carrier threads because they carry the virtual thread. And then they run a virtual. The virtual thread gets put on a carrier thread, and then the carrier thread does the actual computation while the virtual thread, sits there and thinks it's very busy. On a blocking call, internally, the runtime transforms this to a non-blocking call. And the virtual thread thinks it sits in this blocking call, but internally, the runtime does a non-blocking call, takes the virtual thread and puts it aside, unmounts it from the carrier thread and puts it into heap space, where it's just an object, right? A virtual thread is just a Java object living in the heap. And the carrier thread goes back into its pool, and it can do something else. It can compute somebody else's virtual threads. And when the call returns, when this internally made asynchronous call returns, then the runtime realizes, oh, okay, so that virtual thread over there, that can continue now. So it takes the virtual thread and mounts it to another carrier thread, potentially. Could be a different one. And then computation continues from there. So the virtual thread, from the inside the virtual thread, from where your code works, the carrier thread is invisible. You don't know that it exists. You cannot find it. If you wait and you set a breakpoint, you appear to be waiting in the virtual thread where you always used to. It all looks exactly the same. That there's like a whole new carrier thread under that. You have no access to that. Just like you had no access earlier to the operating system thread under that one, right? So if we go to our simple request from earlier, if the request comes in, step one, the runtime submits that task to the carrier thread pool, right? Your web framework says new virtual thread, blah, blah, blah. And then the runtime realizes, oh, there's a new virtual thread. I'm going to submit that to the carrier thread pool, and I'm going to do the computation. And when 2 blocks, I'm going to unmount the virtual thread. I'm going to give the carrier thread back to the pool. It does other stuff there, It computes other things over there. And when 2 unblocks, the runtime resubmits the task. And we continue. So this also explains very clearly why, virtual threads don't make anything faster. Like if you don't do a lot of switching, they arguably could even make things a tiny bit slower because, of all of this thing that's going on. so they're just like in the end, while you're doing computation, it's just a carrier thread sitting on a platform thread. Sorry, yeah, sitting on an operating system thread doing a thing, right? It's as before. The difference is when you're not doing that, when you're waiting. And when you're waiting, the operating system thread that just did your computation is busy doing somebody else's computation, while your virtual thread is just sitting there waiting for the call to return. They work correctly with everything, all blocking operations, synchronized, the thread API, thread interruption, thread locals, native code, everything just works, don't worry about it. But not all of that may scale perfectly. So what we're going to go over now is we're going to go over two like distinct behavior in certain edge cases, and if you feel like that's too detailed, I don't need to know this, that's okay. I'm going to tell you in 10 minutes when to wake up again. It's interesting, I think, and you can make some code changes for this, but again, it's not urgent. It's not something that you need to go through a code base and rip out all thread locals because Nicolai told you so. So the first thing that we can know here is the concept of capture. Capture means that when the virtual thread blocks, it actually captures the platform thread and they both block together, which ideally shouldn't happen at all. And there was a lot of work being done, and these JEPs are two examples for that, where things were changed so this wouldn't happen. But there are two operations where that's still the case. One of them is object wait, and the other one, unfortunately, is file I/O. So file I/O will change. Linux is so I/O U-ring on Linux is becoming a big thing, and there might be a future where at least on Linux, Java adapts to that, and then internally has a way to do asynchronous file I/O. I'm not sure whether that does not exist on Windows. I'm not sure where Mac sits on this. Do they also use I/O U-ring? I'm not sure. Like I'm not. These are a little bit beyond me. But the point is, at the moment, file I/O is capturing, so the operating system thread is also being blocked. And the runtime knows that, is aware of that, and there's really not much we can do as developers about this. So the runtime is like, okay, look, it's a problem. It's not your fault. Here, I'm going to give you a new pool, extra pool. An extra thread, not an extra pool, an extra carrier thread to compensate. There's a limit to how many of those it will give you. You can set that limit to basically infinity on your command line. And in that case, if all your app is doing is waiting for the file system, and you're turning everything into virtual threads, and then the runtime under the hood is like, oh man, like virtual threads and file I/O, that doesn't actually work, so I'm going to give you new platform threads. You're basically getting the exact behavior as before, right? Like in the absolute worst case, where your app only waits for the file system, and you increase the command line flag to tell you, like, let's grow the carrier pool basically to size infinite, then you will get, at worst, the same performance as before. Ideally, your app does other things and waits elsewhere, and then you can still benefit from working when using virtual threads. Okay, so there's nothing much you can do here. Capture, it's a thing, but that might limit your scalability. Another concept is called pinning. Pinning is kind of like capturing a little bit, but also not. So capturing means the virtual thread and the carrier thread are now one thing, and they're both waiting, or blocking rather. Pinning is different. An operation can pin a virtual thread to a platform thread, and then if in the future, if somewhere inside those methods that are being executed, the platform thread, the carrier thread would want to go its own way, and the virtual thread would want to be unmounted, they can't anymore because they're now pinned. That happens for native method calls with JNI, and it happens for foreign function calls with the new foreign function memory API. And the reason for those two are just there's no other way. The reason for that is if your code goes through Java code, then everything that's on the heap can just be rearranged anytime. And but you always where stuff is on the stack you don't care about, right? Like Java does that for you, runtime does that for you. Now let's say you go into native code, and that native code calls back into Java code. What happens then is that the native code can do stuff with your variables, right? And for those, it needs to know where those variables are, and they're on the stack. So the native code gets addresses onto your stack. Okay, so let's say you have this native code, and it looks at the memory addresses it was handed by Java to fiddle around with the stack. It does that a little bit and everything is fine. It goes calling to your Java code. Your Java code does a blocking operation, and now the virtual thread machinery sets in, oh great, database request, whatever. We're going to put that operating system thread away while we're waiting, and when the waiting is done, we're going to take a different operating system thread, put it back under the virtual thread, keep running, your Java code unravels back into the native code, and then the native code is, haha, I still know about those stack locations for the variables. But it's a different thread now. So now it's changing things. Well, I'm not sure whether it will actually be able to do that or whether it will immediately crash, or will only start behaving really weirdly when it starts changing variables in a stack that are now belonging to a different thread that is computing something else. So as soon as you have like one of these native frames on the stack, the whole separating and like mounting and unmounting thing doesn't work anymore. So that's why it's not done, to avoid any of these breakages, right? So once you have a native method call, those things are pinned now, and if they come back into Java and they would want to unmount, they cannot. The same is, well, for different reasons, but also the same behavior is observed on synchronized for now, which will likely be removed in the future as a limitation, which is pretty good. No compensation is done for this. This is only a problem when pinning is frequent and also you're doing blocking operations in there, right? So if pinning is rare, who cares? If pinning is frequent, but you don't do anything blocking that's supposed to be unmounted, you're just doing computation, also who cares? Pinning only becomes a problem when it happens a lot and when you actually want to use the virtual thread I'm waiting for free capability. So the solution here is to avoid long-running pins. First of all, avoid pinning operations if you have the choice, and if you don't have that choice, then try to remove blocking operations out of there. And if you can't do either, that's okay too. As I said, the worst that can happen is you get the same behavior, the same performance characteristics as today. Also, synchronization. I have a split relationship with synchronization. It's very simple to write synchronize somewhere, but whenever I did something, I sooner or later realized that I need a more refined concurrency model. So in the end, I often ended up not using synchronized after all. It often gives you the illusion of being thread safe, but then if you can still have certain edge cases where it actually isn't. Not synchronized itself, that works perfectly. But if you have a complex data structure that can get mutated in different ways, then just having one synchronized sometimes doesn't cut it. You could use a lock, for example, instead. Also, the advantage is that locks do work fine with mounting and unmounting, so there's no pinning involved. Last one, thread locals. Again, thread locals work perfectly fine, but they can hinder scalability. A thread can inherit its thread local to another thread that it spawns, which should see the same information, but because thread locals are mutable, and then both threads should not see the same changed behavior, it kind of makes sense to say, okay, I'm spawning a new thread, I'm giving it my thread local information, but I need to create actually a copy so that mutations don't collide. So they're copied. And that's great if you have like dozens or hundreds of threads, probably. But now imagine you having thousands, hundreds of thousands, millions of threads, and you always copy this thing. And this is clearly a problem for scalability. Again, this will not. If you switch to virtual threads, the worst outcome here is, you get run into a limitation that you also ran into with thread locals before with regular threads. So it's not going to make things worse, but it might not make things better, even though it could. Thread locals have other shortcomings. One of them is the aforementioned mutability, and the other one is that it's kind of easy to create memory leaks with them. Somebody puts something into a thread pool, and then into a thread local, and somebody else was supposed to pull it out later, but something bad happened. Exception, who knows? It didn't happen anyway. Somebody wrote code in a weird way. So now all you're doing now is adding stuff to thread locals without ever removing it. So those kind of memory leaks are also not great. And scoped values replace all of that. But they are immutable though as an exchange. So it's a trade-off. So in the past you would do a thread local like this. You can still. It still works. So this is what this will look like. You create often it's a static final variable for the thread local. And then you do some stuff. You create the instance eventually that you want to put in here. And then you shall call principal set principal. And then you call the rest of the application, which does something, whatever, nobody knows. The important part is the line where you set this on the principal thread local. And you have to put a remove call somewhere, or that thing will be in there for the lifetime of your application. With scope values, it looks a little bit different. The top there is the same. You write scope value instead of thread local. You create the principal, that's as before. But now you say scope value dot where. So where this principal has this value. I wonder why this is a static method, by the way. I have to ask. Like, every time I see the slide, I wonder. And then when the talk is over, I forgot to ask. So you say where this principal, which is the instance up there, has this value, which is the one I just created, in that scope, do the call that I had there earlier. And scope values are immutable, so no copies need to be created, but also scoped value, right? Once the run method is done, the method gets, so the value gets removed again. And so there is no chance for memory leaks. So what can you do to prepare your code? Most importantly, for virtual threads, that means, if you use thread pools for concurrency, replace them probably with semaphores. Maybe you don't need to at all, right? Like if you have different kinds of pools handling different things, if it's all for concurrency, just rip them all out and then see how virtual threads balance that. What you can do if you want to, remove long-running I/O from pinned sections, because there will not be compensation for that, right? Like that's something that can hinder scalability that will remain an issue far into the future. Replace thread logos with scope values. That's something that I think has API and maintainability benefits. But it will also not be fully under your control. Often thread locals are used by the web framework or by logging frameworks, for example. So they're always under your control. And look into replacing synchronized. Even though the limitation that synchronized is pinning might go away, I would still argue that logs are often clearer and clearer to understand than synchronized. But that's just my personal opinion. Any questions? I am online, right? So it turns out later that actually my phone didn't connect and you had a lot of questions anyway. Surprise, I want to talk about deprecations for a moment. I'm sorry, that was not part of the table of contents, but we need to. I'm going to be quick about it. Things are going. We're not just, well, we. I'm not a member of OpenJDK, so I can actually say we. The people in the OpenJDK community are not only adding stuff, they're also removing stuff. These things are already gone. So if you're on Java 11 and you're still, banking on concurrent mark sweep as the, linchpin of your performance, and I'm not joking, I know that some projects are in that situation or were in that situation. That's got to end, though. So concurrent mark sweep is already gone. Nashorn is gone. RMI activation is gone. Nashorn is a standalone project now. So if you need it, you can put it in it as a dependency, as far as I know. But it's not part of the JDK anymore. And these things are deprecated for removal. So that's kind of funny. This is in circles here. You have the Java version where this was first announced, and this is supposed to be a 21 in a circle. But apparently my font doesn't have all the Unicode characters yet. Sorry about that. So imagine this as a 21 in a circle, so Windows 32-bit port, and that dynamic agents are allowed by default. Those things are marked as deprecated, and those things will change since 21. Finalization, security manager, applet API that happened fairly recently, and before that, the primitive wrapper constructors and bias locking. You should look. That's one important takeaway, not just here to talk about all the cool new things. You need to look into all of those to see whether you are using those. And if you are, you need to change that. Those things are not just deprecated because, the better alternatives maybe don't use this. But that's for real, right? They will be removed. I want to go over a few of those quickly, the most important ones. First one is agents. So an agent is a component. It's like a regular jar. Well, not quite regular, but it's some kind of jar that's lying around that can transform bytecode in your running application. It uses the Java Lang instrument or the JVMTI APIs for that. And there are two ways to use this. You can launch it together with the JVM, or you can launch your JVM and then attach the agent later. That's called a dynamic agent. Okay, so I'm only talking about dynamic agents from here on out. The regular agents that you launch with the JVM, nothing changes there. So all mechanisms that have to do with agents, they all remain intact, and nothing changed yet. But in the future, this dynamic attachment will be disabled by default. You have to enable it with this command line flag. In the future, you have to enable it that way. And that's also where it ends, right? This is not, some of these processes like these are the beginning some of these steps like these at the beginning of a longer process, where sometimes things are first deactivated by default and then eventually they are removed. And we will see that. But that does not apply to dynamic attachment of agents. Dynamic attachment of agents will remain possible. It just is something that you have to allow on launch. And the reason for that are all hidden in the JEP, and not hidden, very, very well explained in the JEP. I think that can be summarized as platform integrity. An agent is a very powerful tool that can do a lot of things to your code that make that very hard to predict its behavior. And you should at least allow that to happen and not just let it happen, without you knowing. Okay, so what do you need to know? What you need to do, you can run your app today with minus enable dynamic agent loading. And then you will just look at your app, and if it works fine, all is good. And if things start to work not fine and they crash, that must have happened because you did have a dynamic agent doing things somewhere. So you need to investigate that and figure out whether that's necessary. And if it is indeed necessary, that's fine. Then you will just need to add that flag. So be aware, you could just take away from this, just need to add this flag in the future and all will be good. That is true, but remember, there's a reason for this, and that is that an agent, as I said, it's a very powerful tool that it's like doing brain surgery, right? You don't give that scalpel to everybody. You just want to make sure that it's the right person. Yes?
Elaborate on the legitimate use case for dynamic agents that you see.
I should elaborate on the legitimate use cases of dynamic agents that I see. Actually, so I'm not very much into that specific space, but I want to say I think use cases for dynamic agents are all good. It's just a question of, does every user know what they're doing? And if yes, and they agree, go ahead. So one clear case that's great is for instrumentation, for example, for performance. That's something like New Relic does, for example. And they're not the only one. So they take your bytecode, they put some calls in between so they can measure everything, and then later they give you that thing. Aspect-oriented programming, also something that happens on the bytecode level, where you say at every method entry point, I want to log something, right? So those kind of things are something you can do with aspect-oriented programming. Yes, aspect-oriented programming uses bytecode manipulation that can use an agent to do that. I think, as far as I know, Hibernate uses an agent to observe the change of entities internally. That's fine. All I'm saying is the user should be aware of that, and the user should be required to intentionally set that flag and to know what for. To be honest, I think maybe, I'm not sure, I'm talking out of my behind now. I'm thinking maybe it would be better, just like the add opens that you have, you'd have to say enable dynamic agent, that one specifically. This is the name of the main class that I allow, so I don't allow all of them. But I just made that up on the spot, who knows. Okay, so that's dynamic agents. Let's talk about finalization. What's finalization? Well, you have probably seen the finalize method on object and elsewhere. And behind that method sits a big machinery that's part of that is in the Java language specification. A lot of the actual implementation is hidden in garbage collectors that does some things, right? It's about resource cleanup. It's about, I opened this file, so when you throw away this instance, also close those files. It has a number of glaring problems that you should look into the JEP to know more about. You can disable finalization with this flag. In a future release, it will be disabled by default, and in a later release, it will be gone entirely. So unlike dynamic agent attachment, this will go away. So what you need to do, first of all, look for all finalize methods in your code. And you want to try to replace that with resources. And if that does not work because you have a complicated case, maybe you need to look into the cleaner API. But the cleaner API shares some of the problems that finalization has. And the reason for that is that some of those problems are just inherent in this solution. So that's why they share some of them. So try with resources is the better approach. If you can make that work, that's definitely better. Then check your dependencies. And if the dependencies have finalization, open a ticket, maybe a pull request, try to help the project, bug bounties, all that good stuff to try to help the open source community that your project relies on to go with the times. What you can already do is run your app with finalization disabled and then just closely observe it, right? Specifically, since it's about resource cleanup, look at resources like file handles, for example, or network resources, whatever you think that your app does in interaction with the outside world, with the operating system specifically, look into that, observe those, and see whether there's any change in behavior. And if there is, then that's because somewhere you rely on finalization to clean up something. Okay, next, security manager. Security manager is a system of checks and permissions that is in place, and it's intended to safeguard security relevant code sections. Now, I could have written it safeguards security relevant code sections, but that depends on A, is it active, and B, are you using it correctly? Both of those are way more often, the answer to those is way more often no than you would think. And all of that is embodied by the type security manager. It is barely used in the wild, as hard as it is to collect such numbers. The OpenJDK community can look at code bases that are out there, not only open source code bases, but also, for example, Oracle internal projects. And since this has been discussed on the mailing lists, very few projects have come forward and said, yes, no, we are one of them. It's easy to say, well, projects could rely on this, but not that many have come forward and say, yes, we do rely on this. So it is not very widely used, but it's very maintenance intensive. Every change within Java is considered from a security perspective, and that means many of them have to somehow be folded into Security Manager, and that makes it a lot of work. So it's a bad trade-off, right? It's like it doesn't get us the benefit that we want for different reasons, but at the same time constantly requires investments. Investments, by the way, that could be spent elsewhere in Java security, on Java security work. So that's why it's proposed to be removed. It's already disallowed by default. You have to enable it with Java Security Manager allow. So if you do set a security manager, it will start failing. Maybe it's already failing on 17. I'm not entirely sure anymore when this change was made. Anyway, if you go to 21, you definitely have to set this. In a future release, it will be entirely removed. What you should do is observe your app on Java 21 with the default settings, which disallow the security manager, and see whether anything breaks anywhere. Like if somebody sets the security manager, they will get an exception now. So unless that code just silently eats the exception, you should see something somewhere. Either it's just plainly failing or something in the log. And if you use it, figure out what the use cases are and try to move away from them. The JEP has a lot of alternatives that you can use. Okay, last one on the deprecation front. Let's talk about primitive constructors. What are they? Well, these things, you might have typed them occasionally. Valhalla wants to turn integer, long, double, all of those into value types, and value types do not have identity. That means if I create an integer 42 and then another new integer 42, then those two instances are equal, but they're not identical. They're not equal sign the same thing. They have some property, some ephemeral property that goes beyond the values that it embodies, and that is called identity. And you use an identity, for example, to lock. For synchronized, you want to lock on that specific instance, so that instance needs to have identity. Something else that deals in identity is a constructor, because a constructor tells you, I'm promising you to give you a new object that has not existed before with this value. The constructor is disallowed from just saying, hey, I have another 42 lying around, I'm just going to give you that 42. That's not allowed. The Java JLS is extremely specific on that. So these new value types that do not have that kind of identity kind of clash with constructors because they are identity-based operations, and so they need to be removed. And so they are currently deprecated for removal. What you do instead is use this, which is super simple. Damn, I'm now blanking on the name. Open rewrite, right? So there are tools out there that help you with this. Like this is very, this can actually be a cleverly written regex that does this replacement. You don't need to write those regex yourself. There's tools like Open Rewrite that help you with recipe-style replacements like this. So if that's something you need to do, please don't just go through code base manually, like searching for a new double. There are better ways to do it. If you want to look more into this, and even though it pains me to say this, this is probably the most important part of this talk because everything else will just work its way out, right? Like you will just see pattern matching somewhere and you will start using it because it looks good, and then you will maybe be disappointed or not, and you will use it more or less. That happens on its own. The stuff that I just told you about does not happen on its own. You actually have to do it, and you have to do it soon-ish because these things will not be around for another decade. I don't know any time plans, I don't even know whether they exist, but if all of that still exists in a decade, and it's a lot of slides back, I'm sorry, I'd be surprised, extremely surprised. So please follow up on all of these JEPs. And yeah, at the end, also want to quickly go, there were 2 more things except the JEPs, which is I did an Inside Java newscast on that. And then the last one is how to upgrade to Java 21 specifically, which also goes into a little bit detail on this and also on other minor changes, which I didn't go in here, but you should probably check the video for that. There have been some bug fixes and some other behavior changes between 17 and 21 that you might run into. One funny one is double toString behaved in a weird way, where if you had a number, like if you had 1.0 and then like, I don't know, 20 zeros, and you would tell that, give me a string representation of this, it would give you 9.9 with a lot of like, with 19 nines, which is, you know, close, but not the same number. So it would pick like the wrong string representation occasionally. And that has been fixed, which you probably know the XKCD joke. Everybody's bug is somebody else's like behavior that they rely on. So go watch the last video, how to upgrade to Java 21 to get an idea of all the small things that change here and there. If you don't do this and you run into them your own, keep in mind there are release notes for every Java release, and they list in excruciating details all the things that could go wrong. So if you do an update from 17 to 21, try 21, and as soon as you see issues where you don't know the solution, go back and try 18, 19, 20, 21. If you find, like, those old builds are still around, you can find them online. Don't run 18 in production, nobody gives you support for that. It's utterly unmaintained, it could be full of glaring security holes, but you can run it in your build locally, and if that works, try 19. If that works, try 20. And if that fails, you now know which release notes to check. You know what to search for online. So if the 17 to 21 step proves tricky and you're like caught in some like detective work, remember if you go version by version, you have a much cleaner angle and you can see much more clearly which version's at fault, and then you can investigate that. Okay, upgrade pains used to be my shtick back in the day, so I kind of still like talking about that. Ask me later if you have any questions about that. Now let's talk about something else. Let's talk about something fun again, something that you can play with if you are willing to play with preview features. Let's look into string templates. Again, I'm going to do something that most of you will feel is really bad. And if you leave before I'm done with this section, please don't do this in real life. I'm going to show you something better later. What I'm doing here is I'm creating SQL injections. Sorry, I'm creating an SQL statement as a string where I put stuff together, where I say select star from person P, where person P dot whatever, last name, is equal to the value do. And I can do that with a string concatenation. I can also use formatting. There is at least two more approach, right, like string builder, and then there's this other kind of string formatting, message formatting, whatever. So there's plenty of ways to do this. And it comes with a free SQL injection if any of that is provided by the user. And that's kind of cumbersome, right? Other languages allow us to do something like this. I use the / curly brace here because, spoiler, that's what it's going to end up being. But, you know, I'm just imagining making up some syntax here where I can just embed a variable here. Other languages let us do that. They give us our SQL injections much faster. Wouldn't that be good? Okay, moving past SQL injections, generally the strings that we create are not actually meant for other people. It happens, you know, error messages, UI text, but it's not the norm. The norm is we create structured text for other subsystems, SQL databases, JSON parsers, whatever. Like we create something in a language that another system understands, and they all have format-specific rules and everything. And you know, we talked about records earlier when I said, don't create them in a broken state and then try to fix them after. And that's kind of what we do when we create these things with strings first. We first write out the string, and then the string runs around the system, and hopefully soon it gets caught somewhere by somebody who says, like, wait, this is not actually syntactically correct. So as a preview feature in Java 21, we get this beauty. So first of all, I'm using a text block here. I could have used the text block before. String literals or text blocks have no bearing on this feature at all. I'm just using whatever fits better on that specific slide. Two things to point out here. The / curly brace indeed is the new syntax which I can use to embed variables. My code highlighter clearly doesn't understand this, so it puts everything into gray. But you know, in some futuristic version of this app, of this library, I think it's highlight.js, this is going to be white. And because it's a reference to the variable property. and so is this to the variable value. So the first thing we see here is this embedding of variables. Actually, I can embed expressions. I can put method calls in there. Heck, I could put like a stream pipeline in there, although I would recommend to keep it small and short. But yeah, you can put stuff there. That makes it a string template. That's the first part. The second part is this weird str thing here. That's called a template processor. Specifically, this thing is an instance of a class that I'm going to show you later. So the part where it says str period, that's just a method call. There's no magic there, right? It's just I'm using an instance that I have available, dot, now comes the method name. And that's the only magic. The compiler magic for this specifically is, look, you don't have to write a method name here. You can just immediately put the argument. And I know some other languages allow that in general, and now people will be like, can I do this for my function? And the answer is no. Maybe it changes in the future, but for now you cannot. You cannot write f.to instead of f.apply to. I don't know whether that's maybe opens the door that way, I'm not sure. Anyway, first thing, string template with these embedded expressions. Second thing is this processor that takes a template and turns it into a string. See the asterisk at the bottom, we're going to come back to that. This is one example. There is a template processor called str, which I don't know what that means. String, probably? But the other one creates a string too, and it's called, and it doesn't matter. Like, I don't know. Like, but maybe we ran out of letters. That's the only good explanation I have for this. And this is a payment slip, right? You have a description, a desk variable, a price variable. Those are referenced here. We can do some simple math. And then the str processor is super stupid. It does nothing fancy. It just, the expressions are all evaluated. That's like a normal Java method call, right? So the math in there, like price times quantity, that happens outside of the control of the processor. That's just computed, and it's passed into the template. And then this template processor does nothing but just create the string and just put the values at the right places, and that's it. It's done. And that works kind of great. It has the specific downside that I now need to figure out how to pay 0.6 dollar cents. So yeah, that's what I could use another processor for. This one's called FMT, which I suspect stands for format. It understands the string.format, formatting substrings, right? So this stuff means, I always have to look up how to read them. Correct me if I'm wrong. Float, and then 5 positions in total, and 2 after the period. Maybe is that what I mean? So at least that's how it works out. Like we have 5 locations, a length of 5 here. That means you might have to round, right? You only have 2 positions after the decimal point, so you might have to round. And lo and behold, it's now rounded to 2 positions, and we get the result. This template processor needs to be much, much smarter. It needs to look into each injection point, into each point where like a value comes in, and then it needs to scan backwards to look whether it finds one of these formatting strings, and if it finds it, it needs to interpret it and then remove it so it's not in the output. Right, so this one is much more involved than the other one. Both of these are on board, str and FMT, and they are exported in a way just like Java Lang, basically. Like you don't have to import anything from Java Lang, from the Java Lang package, and these two you also don't have to import. You can just use str dot wherever you want. Okay, why do we talk about strings though only? As I said earlier, like we often talk to other systems, right? And for some of those systems live in the same space, in the same subsystem, like my database driver is right there. And often we start with like a string that has some values, and that distinction is kind of important for when you want to parse it. But then if we really just take the string and put it together and then parse it and then create a string, then later, if we pass that string to the database, it would need to parse it again. So we internally creating like a rich interpretation, which requires some work to make some checks whether it has the right syntax or whatever. And then we create one of the stupidest data formats that we have, which is a sequence of characters. And then later somebody else has to do it again. Why the detour? And the answer is no good reason. So we don't do this anymore. This is the interface I mentioned earlier. It's an internal interface of another class. It's called processor. It takes a string template, has a process method, right? That was the dot process that we didn't have to write, but it returns a result, which is of any type. So we can all create template processors to our delight that return whatever we want. For example, you could have a template processor that does this. That is called SQL. And it could be a static instance somewhere. Sorry, I don't call it static, but what I'm saying is like it could be just like a general SQL thing somewhere. But it could also be something that is injected by Spring Boot and that was instantiated with our database connection information. So what this could actually do is it could do the right thing, which is create a prepared statement and then drop the values at the right places, right? And then give you back an SQL statement. This could be the java.sql.statement there at the top left. If you want it as a string, you can still call to string on this, or maybe you have an SQL str version that I don't like. Again, we can make up our own stuff here, right? You can do the same thing for JSON. Jackson could give you something where you write JSON and then you write something that actually looks like JSON and it gives you back a parsed JSON object that is validated and escaped and all of that can definitely use as a valid system. And I think that's just so cool because it combines the ease of use that Plus does not afford you. Specifically, Plus together with text blocks is like, it's ugly. So that's one good part, but the other good part is that it forces you to make a decision. You always need to do something here, by the way. You cannot just like let this go. You have to put something here. And so you always have to make a decision. And so by default, you should not think I'm putting str there. You should think, but what's the domain I'm working with here? And shouldn't I have a template processor specific to that domain, to JSON, to SQL, to XML, whatever you're doing, right? So yeah. That's I was thinking like maybe you could use JUnit to write tests this way, right? Like some people really like it that like in Spock where tests are basically more like free text, and because you can return whatever you want, you can return JUnit 5 was like a dynamic test instance or something. So I think there's a lot to explore here. Basically now Java gives you the ability to whatever consists of a mixture of characters and values. You could use this and try to create something meaningful from it. I mean, it doesn't work, and probably it's not. It won't revolutionize all areas of Java, but I think there are some spaces which can really benefit from this. I mean, the SQL one is an obvious example. Okay. As a summary, string templates do simplify string concatenation. They allow domain-specific processing, and they incentivize using it the right way, where it's not just let's concatenate all of this to strings, injections be damned, and then later try to figure out whether that was correct actually. Instead, you always put the right processor there immediately. I just now noticed that I don't have a more section for this, which I'm sorry about. There are definitely follow-up links. If you're interested, I can give you some later. Okay, do you have any questions about that? String templates. Again, it's a preview feature in Java 21, and I'm not sure whether there's already a JEP drafted for the 22 version. So, preview features in general don't write a lot of production code based on them. Those preview features are not like alpha or beta features. They're not substandards. They don't have terrible performance or are unsafe or whatever. The only thing that distinguishes them from like a non-preview feature, from a finalized feature, is the likelihood of change. A normal finalized feature has basically no change ever in the future, and a preview feature might. But all that means is that you might have to rewrite some code, which if you're willing to do that, you can use preview features. I'm not advocating to use them in production, and definitely as a library writer, you should not use preview features and give that to your users, because there's like version pinning and all kinds of things involved. But if you want to experiment a bit with one, and you want to write your tests, let's say in your tests you're now going to use string templates. Sure, go ahead, do that. Just don't write 2 years worth of tests with that feature, and then realize some detail change, and you have to now rewrite 2 years worth of code. But if you want to experiment with that, I highly recommend to do that and give feedback. Or like internal projects or demo projects, anything that doesn't accrue like a dozen people working on it full time. Because then, it's a lot to rework. Good, let's talk a little bit about these new and updated API changes. There's so many that don't even fit on the slides anymore. Let's talk about a really simple and good vibes one, that's sequence collections. So, list has two properties. It has an order, in the order in which these things are in the list, and it gives you indexed access. That's what the list embodies. A collection is just a jumble of things, and a list says, yes, I'm a jumble of things, but these things are coming in order, and I can give you an element at each position you want. Then we have a bunch of collections that say, yes, we also have an order, but what we don't have is an indexed access. So sorted set has the sort order as order. A dec, or DQ, it's called dec, but I don't know, I like DQ better, whatever, has insertion order, whatever in order you insert, that's the order that they are in that data structure. Linked hash set has insertion order, and I found out yesterday, to my extreme surprise, it also has least recently used order. So who knew that? Like, because I didn't. So what you can do is with the, oh wow, what you can do with the linked hash map is, every time you call get, it changes the order, which is just like mind-blowing, right? A get is not an idempotent operation. Every time you call get, it rechanges the order, and the next time you call give me the first element, you get the element you last time called get for, which is crazy. Anyway, I mean, it's a cool feature, but a get that mutates the underlying data structure, I'm not done processing that. Good. So what we're doing here now is we're capturing this concept of order. We call it a sequence. A sequence is a data structure that has this order, but it does not necessarily allow you to access things at an arbitrary index. All it tells you is, look, the order is not unpredictable. It is predictable, and if you iterate through it, you will always see the same order if you don't change anything, but I'm not willing to commit to giving you things at a specific index. So we have these new type sequence collections, sequence set, sequence map. We're going to focus on the first one. The rest is analogous to that. And you can use it obviously as a parameter or return type, and you can enjoy the new methods. So let's have a look at the new methods. Getting the first element on a list is no problem. Sorted set and deck make it pretty easy. But you know these types where you have to say like, okay, give me like the iterator and then call next, and then somebody points out, well, but if it's empty, you're like, oh my God, okay, first I have to do has next, and then that's terrible. Now you can just call get first on all of them. So because all of these implement the sorted sequenced collection interface, then now I have a got first method. Removing last, that's even more fun. Just to give you another example, like getting or removing the last list element always required this like dance through hoops, which is terrible. Sorted set has a remove, and then you can ask it for the last set, so yeah, that works. Linked hash set, yeah, no, it's just like you can't even get the last element. You have to iterate all the way to the end, and then tell the set to please remove that. Now you just have remove last. You want to do stuff in a reverse order. How do you do that? With a list iterator, you can actually get an instance of list iterator, which not only has next and next method, but also previous and has previous method. Navigable set is pretty cool. Gives you a view called descending set, which is a view on the original collection, just the other order. Deck has something similar for an iterator. And again, linked hash set is like, nope, I have no idea, you can't do this. You have to iterate through it one order, write everything into a different collection, and then reverse that one, or like put it into a correct position in a whatever. It's terrible. Now you just call reversed. And reversed gives you a sequence collection view. So that means two things. Let's go with the first one. It gives you an instance of sequence collection. And a sequence collection is, well, it's a collection, so you can do whatever you want. You can just write a for loop. You can just call reverse.stream. You can just do reversed and then to array. Or whatever you can do in a collection, you can just do on the reverse. But it's also a view. And the fact that it's a view means, for one thing, it's very cheap, right? Calling reverse is just an instance creation. So don't worry about reversing a huge array list. It's no work. It's just giving you a view. And it also means that mutability goes both ways where it is feasible. So I'm having this list of letters here, ABC, and I put it into an array list so I can actually change it. So now letters are ABC. Now I say letters reversed, remove the first. And that removes the C. So now letters is AB. So that's sometimes good and sometimes bad, right? Views have this characteristic that they do change with the underlying collection. Sometimes that's what you need. Sometimes that's what you want to avoid. If you want to avoid that, if you want to get a reverse snapshot that never changes, you would do, for example, like var reversed letters is new array list of letters.reversed. Right? Then you create a copy. Okay, so to summarize, these are the new operations. Add first and add last, get first and get last, remove first and remove last, and then also you get reversed. And for the sequenced set, these are all the same, but here you get a sequenced set back, so that when you reverse, you still have the guarantee that it's a set. And for map, you have the same thing, but with key and value and entries, and it's a bit nasty. Like the names are slightly different. Let's ignore that here. Now I have a question. So let's say I do this. I have a sorted set, and I create it with BAC. And a sorted set will then sort them into the right order, ABC. And then I say at last, D. So what could happen here? The first option is this always works. So if I say at last A, it still works. I told it to put A at the end and sorted set contract be damned, we're going to have an A at the end. Who thinks that's a good idea? Good. Okay, I primed you correctly. The value fits. I mean, so you could let this one go. So at last A fails, but at last D, that one works. I mean, it makes it kind of hard to predict, but I mean, so who thinks that's the solution we're going with? Oh man, I'm doing this great. Okay, because what I'm telling you is this is what happens. This just never works. So we have a method on the interface that's one of those, you know, like all the mutable methods on all the collection interfaces are like, I mean, yeah, they are here, but yeah, everybody can throw an exception and just not implement that. And usually that happens in a way where an entire collection says, no, I'm immutable. I'm not going to allow you to add, to clear, to remove. None of that is allowed. Which, you know, it's a little bit sad that we don't have an interface for that, but it is what it is. This one is a little bit odd because you can definitely call set, sorry, not set, but you can add to that sorted set. You can just not set at last, which is unfulfilling that now another method throws an unsupported operation exception, but I'm glad that I got you to this point where you agree it's the only viable option. But those are not only operations. I mentioned earlier, use them as types. And like a general piece of advice that I want to give you is, when you write an API, use the most general type that has the API that you need or that you support, depending on whether it's a return value or parameter, and that plays the role, right? Sometimes you're like, oh, well, iterable has everything I need, but really I'm dealing with a collection here. So, you know, then maybe still use collection. But if you talk about collections, actually, I think the right interface is much more often collection than we give it credit for. Very often I see lists and sets being thrown around, even though the methods that receive this do not care at all. They do not care about ordered access, indexed access. They do not care about uniqueness. All they need is something to iterate over, right? So collection would be perfectly fine. So in general, I want to advise you, try to find the most general type that fits your API and fits your needs. And in the case of collections, that's often the collection interface. Less often it's list or set themselves. Definitely never array list or barely ever array list. Like I think I've never done this intentionally. But now consider the new types, right? Consider where the new types fit in. Do you need uniqueness? Then it's a set. Do you need sequence? Maybe that's a sequence set. This is how it fits into the inheritance hierarchy. This is in the JEP that Stuart Marks wrote. So I'm not going to leave this up too long. You can find that in a link in a second. Yes. So right, you can see collection here, and then sequence collections comes below that, and then set is here, and then sequence set inherits from both of those. So both of those semantics are inherited there, and then you have the whole map tree off to the side there. If you want to learn more about this, there's the JEP, definitely read that, or if you prefer video form, there's a video about this I made in March. Okay, 13 minutes left. We still have, oh yeah, there was a question. Did I see this correctly? No? Yeah. Go.
The linked list.
Yes.
I think that's more like a sequence than like a list in this new world.
Yeah, so the linked list, I mean, the linked list has the list contract. It's definitely, everything that's a list is automatically a sequence collection. The thing with linked list is that theoretically it can have a performance advantage that barely ever materializes in reality. So linked list is a bit odd. It's really rarely used, and I think for good reason. But yeah, it has the list semantic, which is a specialization of the sequence semantic. Maybe if we take away indexed access from the list, and it becomes something that's not here. I mean, that's clearly not possible, right? But something that doesn't live here, but it lives under sequence collections would even make that bit better, because linked lists are not that good at indexed access on modern hardware. Okay. Right. Yes?
There is no chance they're going to be deprecated in some future release.
You mean linked list? Yeah. So the question is whether linked list could be deprecated in the future. I mean, we can deprecate whatever, but is it deprecated for removal? And no, I don't think so. I mean, as long as vector is still around, and I mean not the new kind of vector, right? Like the old, like vector and hash table. I think as long as those are still around, linked list is pretty safe. Okay, let's talk. Wait, what do we have here? Anything that fancies you on this list that you want to talk about briefly? Although performance security is very slim, I didn't even get to the security part because I think we would run out of time, and I was correct. Is there anything that you want to see? If you yell loud, I will hear you.
Yes, the address resolution.
Oh yes, address resolution. Okay, good. So the JDK has a built-in resolver for host names, right? Like hostname, github.com to IP, and that usually uses the hosts file and the DNS system, and that's okay. But the interaction with virtual threads isn't good because of the file system access, and it doesn't support alternative protocols. And if for testing or mocking you want to redirect stuff, it's not that easy to do. And we want to fix all of that while staying backwards compatible. And the solution for that is to allow a pluggable resolver. So two new types have been added, I think, in JDK 18, which is inet address resolver, and then above that, the inet address resolver provider. Come on, there's like some good Java names there. So the old resolvers use this new infrastructure as well, and they will just be the default, right? So if you don't do anything, you get the old behavior, everything's good, but you have these two new points, or rather it's 1 point, to plug into. So let's build our own pluggable resolver. So these are the types as they are. So that's inet address resolver provider, which has a name, but then gives an actual resolver, given a configuration, returns a resolver. And then the resolver has to, given a host and a lookup policy, return an inet address, or a number of them, and the other way around, giving an address, returns a string. So that's the API that we need to implement. And what we can do very easily is implement a transparent custom resolver. So first thing we do, we have to go into a module declaration. We're all building modules, right? Good. And I say I'm providing this inet address resolver provider with my transparent inet address resolver provider. Okay, good. So I'm providing this abstract class with this specific implementation. And what the specific implementation does is, well, it has a name that I cut out of here, but it's also there. It needs to give you the actual resolver. And so given a configuration, I create a transparent inet address resolver, which I'm going to show you in the next slide. And I'm going to pass along the built-in resolver from the configuration. So this is just the factory class, right? It doesn't really do anything. It just creates an instance of what I actually need, and it passes on some information. And this would be my transparent internet address resolver. I call it transparent because it doesn't do anything, by the way. So it takes the built-in resolver and it just assigns that to the field. And then it could actually be a record, I just noticed. Well, no, probably not. Anyway, so if you ask me to look up a name, I'm just going to ask the built-in resolver to look up the name. And if you ask me to look up an address, I'm just going to forward that to the built-in resolver. So what we now have is a transparent custom resolver that just does nothing. But now we can just change code here and there. Maybe for that internet address, I want to go there. So we can now fiddle with this. You can think about possible resolvers for like stuff like quick TLS or HTTPS for DNS resolution. You can redirect host names to local IPs for testing. That is something I want to look into in this JUnit 5 extension project that I have. That sounds pretty cool. And I'm sure there are more ideas out there, but I have to say, I'm not the networking specialist, so I don't actually know whether there are more ideas. If you think there are more things, cool things you can do with this, please let me know. I want to put more on this slide. If you want to learn more about this, have a look at the JEP. It goes into a lot of detail. And yeah, that's that. Okay, I want to go to something at the end, the on-ramp, for the last couple minutes. I'm going to take all of your time, and then I'm going to let you go. So, Java 21 makes it easier, specifically for new developers and new Java developers, to get started with Java. But then, specifically in a conference like Devoxx, right, which is full of just Java experts, people who are willing to spend their time and their company's money on coming to a conference and be here for a week to learn about their job. Clearly, we are people who are more than average interested in Java. And so we all know those Java details, the IDEs, the build tools, right? But even at conferences like this, you often, specifically actually at large conferences like this, you always meet people who actually don't do a lot of Java anymore or are coming back into it, like maybe they've just started recently, so I don't think we actually know all about them. What about your kids, for example, right? Maybe you want to tell them Java, talk to them about Java, and maybe installing IntelliJ is not a good first step for them. Students who want to learn, right? They're already using Visual Studio Code to program. They're already, having some experience. They don't know any of this stuff, right? We want to start explaining to them, like, yeah, no, sure, it will be fine. Just install Maven or Gradle first. Then there are front-end developers. They're actually experienced and competent developers who are used to one tool chain. Now they have to learn a different tool chain. And the simpler that tool chain is, the simpler that learning experience is, the better for them. We actually kind of would want some machine learning and AI folks to start using Java more. And if the first example you give them is, we'll need this IDE, this build tool, and this monstrous class of like 18 lines before you can start going. Well, not 18, but what is it, like 10 or something. It makes the initial bump for them harder than it has to be. So Java needs to be approachable. It needs an on-ramp for new developers who are new to programming and or new to Java. And for a simple Java program, that's actually quite challenging. You need a JDK, you need an editor, which you could use an IDE for. You need a Java C or a build tool or an IDE. You need the Java command itself, again, or an IDE, and then you need some Java code. So the IDE seems to be the answer here, but for most people, an IDE is the most complex program they ever saw. Surely was the case for me until I started video editing. If you write Java, like the code, Java code itself also isn't trivial. This looks great for most people who wrote Java for a long time, but you know what's in here? Visibility modifiers, right? You have two publics there. I have the difference between classes and methods I need to explain. It took me a whole while to understand what static means and what the difference versus instance is. I mean, it's sort of keyword, right? But the concept. I need to explain what a return is. I need to explain what parameters are, what statements are, what arguments are. I need to explain all of that. Or I need to tell somebody who learns to ignore most of that, which is also not good when somebody is naturally curious and you tell them, shh, ignore that. It's too complicated for you. Let's focus on the thing that I picked was important. That's not a great way to learn. So that's a lot of tools and concepts that we need. And this separation, this kind of like detailed tool chain and detailed language model and APIs, that make Java great at the large-scale development that most of us do. But they make it harder to get started, to approach it. I mean, even for small-scale development, that actually all that stuff is pretty cool if you already know it. But if you start with small-scale development and then you have to go through this entire learning track of learning so many things that will mostly be irrelevant to you until you start large-scale development, that's an issue. So let's change that. Java already went into JShell, do that a bit. With JShell, you just need the JDK itself, and then you open JShell, and you only need to know what statements and arguments are. You don't need to know what classes are initially. You don't need to know what public means or static. You can just go. That's really good. But I personally don't think it's actually that great for beginners because like this shelly environment, first of all, is very nerdy in a way that like if you don't like the command line, that's actually, I think, challenging for people, but also it doesn't give you like, it's hard to go back and edit stuff. I think, for me personally, when I started using JShell, I often ended up just having an IDE open anyway and just create a main method there and then go back and forth there. So I think JShell is cool, but I don't think it's great for beginners, my personal opinion. All right, and there's no progression. You learned your stuff, few new statements, and you did your thing in JShell, that's good. What's the next step? Well, the next step is everything I told you before, and then you copy-paste over the code. So we need more. One important step was the single file execution that was added for Java 11. Now you can just go Java and then the Java file. You don't need the Java C in your toolchain anymore at all. But there was still no progression. As soon as you needed more than one file, you still had to go through the whole shebang. So let's see the single file execution as one pillar of this on-ramp. And let's build it out in two directions. One of the directions is, let's remove a number of Java concepts so it becomes even simpler to start. And the other direction is, let's make it easier to go from there onto the highway, and in between you probably want to have more than one source file. So Java 21 has a preview feature. Remove the requirement of all of this from your main method. Doesn't need the args parameter. Main doesn't need to be static, doesn't need to be public. The class itself can be removed, and this is all the code you need if you enable preview features in Java 21. If this were Apple and I would be a better showman, everybody would be clapping right now. It's pretty amazing. Anyway, so you can just go vote main, and then you just write your statements, and there you go. That's, as I said, a preview feature in 21, which at the moment means the poor Java beginner now has to write Java -- enable preview -source 21. We're getting there. Nobody said we're getting there fast. And the next step, and we have a JAP draft for that, and I can't wait for this to appear, is to have multiple source files. So one way you could use this is you have multiple source files here, and then you have a, in this case, a subfolder that might have some library jars. Where to get them is still troublesome, because unless you do have a dependency management system, how do you get all the jars you need? So that's part a little bit shady still, but if you get them, it works. And then you will be able to do this. Java class path is the lib folder, run my program. And then program has a dependency on helper, and the Java launcher realizes, okay, so let's look for a helper file, helper class in the same directory. It does all this in-memory compilation, and then executes the code. So now you have a great progression. You can just start with main and throw that at Java, and that's good. And if you need arguments, you start looking into the args. If you need organized code, you can start adding methods. If you need to share state, now you want to add fields. If you need more functionality, you can explore the JDK APIs. If you need even more, maybe there's a simple library that helps you that you can just pull in. If you need more structure, you can start splitting into multiple files. And after that, you can even use visibility and packages. They also work. I didn't show that on the previous slide. So there are two great things about this. One of them is the best moment to learn, from my point of view, is when you have a problem and I can teach you the solution to that problem. If you come to me and say, this is my problem, and I tell you, great, use pattern matching, then you will never learn that fast and that intensely like in that situation. And that's all like that, right? I'm only going to explain to you when you need the thing. But also, you can do that in any order you want. Not any order, but there's different order. It doesn't have to be this one. So this gives you, you start much simpler, and you will end up knowing more or less everything anyway, but the paths there are much more varied and can just follow what your desires are. So Java's strengths for large-scale development make it less approachable, the detailed toolchain, the detailed programming model, but new features will make it easier to start and allow a gradual progression, and hopefully, the average age at DevOps will not slowly creep above 50. Good. Brian Gates has a keynote on Wednesday at 10:20, where we will announce, hopefully, announce something in this space. I'm not going to spoiler it here. But then there's the JEP for simpler main and the JEP draft, and I made a video about this as well. And now I thank you very, very much for your attention. So you can just if you need to leave, don't worry, get up and leave. Otherwise, if you like this kind of stuff, check out insight.java, check out the Java YouTube channel. I'm NePathX everywhere on the internet, and I'm also NePathX right here, right now, so ask me questions if you have any.